All right, so hopefully all of you are here for the bomb masterclass at AEC Tech. If you're not, get out. Just kidding. You can stay anyway. Let's see. First thing we wanted to do, if you are not in the Slack channel, you may want to go ahead and download Bomb. So you may want to do that while we are presenting. If you go to bomb.xyz, you will find the download for the 4.3 beta installer. It should just take a minute flat to download onto your machines. So we'll want to do that first. And then we also sent around a link to the Google Drive that has a bunch of scripts inside of it that we will be running through. I can go ahead and send that around in the chat here, or Eric, if you want to do that actually, so that we can do that while we are in the middle of the presentation.
Yep, just sent out both of those links in the chat, so everyone should have them. And if you're having any issues downloading those, please just speak up, let us know.
Perfect. So during this course, we will be introducing open source BOM's foundational concepts. We open sourced in 2018, so it's been a few years now. We're going to walk through its interoperability features. Love that that's what some of you are here for specifically, and display several of its toolkits in the context of industry workflows. So we'll be going through our LCA toolkit for analyzing embodied carbon, our diffing engine, which is used for change control, Revit toolkit, everyone's favorite software, and Structures FEA adapters, which hopefully some of those appeal to your interests specifically. However, there are lots of toolkits in BOM. So if there are others you want to know about, again, please just speak up. So the agenda for today, we'll be going through BOM's foundational concepts at about a 20-minute presentation. We'll be going through our proposed workflow for the masterclass, and then we'll have a two-part demo. I'll be doing the first part, Eric will be doing the second part. They have interop with each other, and we'll have a couple of breaks in between there. So if you missed our informal introductions at the beginning of the meeting, my name is Kaylee Howd. I'm the Global Computational Community Leader for Bureau Happold. I'm responsible for our academies, which used to take place in person. So I've been to all of our 17 offices globally, used to doing hacks. And now we've been doing those in a virtual format, which has worked surprisingly well. So hopefully this works well for all of you too. And I'm joined by my colleague, Eric Nardi.
Yep, thanks, Kaylee. So again, in case you missed the intro, I'm an architect by background, so not an engineer, and tend to work between the engineering space and the architecture space and the computational space. That's kind of always been my modus. So I'm really interested in how design is affected by computation and how design, computation, and the analytical side and the making everything real side all come together to ultimately end up in something that's a better result for everybody rather than what we see in some projects where it feels like everyone's just making optimizes the whole time. And I think computation is really key to that. And for us at Bureau Happold, developing the BOM and using the BOM on our project work has proven to be a really good solution for that problem.
Thanks, Eric. So I think in that vein, we wanted to start off by framing the challenges that we're facing as an industry. As you all may be aware, we have one building that's built at the end of the day. However, throughout the design process, that has several permutations through the consultants that are hired for the model, whether it's structure, architecture, MEP engineering, IT, AV, city planning, all of those different things have permutations of models. Each of those has analysis packages that it uses to analyze their particular trade, and lots of different software packages that go along with that. And all of those are supposed to funnel into one thing at the end of the day. We're all very familiar with the pains that go along with having all these different software packages and the lack of communication, collaboration, interoperability that happens as a result. So lots of ways to represent a design, and each of those depends on the performative questions that we're asking. Yet there's one design, so we require a degree of compatibility between them. Our solution to that is BOM, which is the Buildings and Habitats Object Model. Our goal here is to connect everything to everything, everyone to everything, and everyone to everyone. I know this is framed as a computational solution to this. However, it's allowed us to communicate in a very similar way. So Bureau Happold's a global practice. We have lots of offices around the globe where a few years ago you may have heard people saying, yeah, I know we do, we both do mechanical engineering, but it's different here. It's different there. Thermodynamics, physics doesn't change. And I think we've learned a lot in terms of coming up with a common language and agreeing that we do have a lot more commonalities than differences. And when you start to break that down, the conversation becomes a lot more fluid and easier. And we've found that using a common language in code and computation has made that much, much easier. So a bit of proof of concept here of connecting everyone to everything here. On the right side, you'll see individuals who have contributed code to BOM. Those are within Bureau Happold and also outside of Bureau Happold. And on the left side in blue, you'll see the packages of code that they've contributed to through our toolkits. So really is a kind of nebulous form of individuals contributing to code back and forth. Our code development metrics, this is a little bit out of date. We had 81 contributors to our open source code, which is a bit unprecedented, 120 repositories, and over 500,000 lines of code in total. I know this number has gone up significantly since then, but just a little bit of a peek into how collaborative BOM is. And a bit of foundational concepts here to cover. It's BHOM. So of course there's an object model behind this. So we have got discipline representations of those objects. We also have our adapters, of course, connecting different software packages together, and the engine, what you do with those objects. So a bit of how we've structured our OM. It's defining the elements we use every day on our projects in the way that we as the experts understand them. I know a duct very well because I'm a mechanical engineer. I would have no business defining a beam. However, there are concepts that relate between the two of them, such as that you would have a start node and an end node, and maybe a center of radius, something like that. So here we've got a circle, which would be defined as a century. Please do not mind the British spelling here. You'll see it all over the code in BOM. So we've got the center, the normal, and the radius. You, of course, have a radius and not a diameter because you're defining it by a single property, not ones that conflict with each other. And all of the derived properties, something like a diameter, would come in the engine method. So we've decoupled those two. So the way that we've defined a structural bar, like I mentioned, you would have a start node and an end node. You'd have a section property, the orientation angle, release, the FEA type, support, offset. Those are the very few properties that we've decided define a structural beam. And you will see through the OM that we've got lots of different objects that we've defined here, hundreds of them. It's probably close to 1,000. But if you look under structures and elements, you'll see that a bar is defined here. We've also got node, panel, column. Column is bar, sorry, not its own object. So lots of different objects that we have defined within BOM, and you'll see that that's all reflected in terms of the properties on the node within Grasshopper in this case. Now, if we come back to this concept of the OM, the engine, and the adapters, if we take a look at the engine, this is what we do with our objects. So we've categorized those by function. So create, modify, query, compute, convert. Those are all typical bits of language you'll see around our engine method. So in the case that you want to flip a bar, that would be a modify engine method. And you can see that that's, again, very simply laid out. And then if you start to combine the idea of the OM, the engine, and the adapters that work between software platforms, that's what we consider to be a BOM toolkit. So in terms of public toolkits, there are tens of them. A lot of those are adapters for specific software packages. Some of them are more conceptual, something like the Lifecycle Assessment Toolkit, where it's not a piece of software, but it allows you to do something very specific and requires its own objects, like an environmental product declaration, which we'll go through later. We also have some closed source toolkits. Those are things we either just use internally, don't think that they're that important for external use. However, always open to moving those across. So if there's something you see that's interesting, let us know. Here we've got our different packages. We've got 36 open source adapters to different software packages. You can see them all laid out here. So everything from Revit, Rhino, Twitter even to data mine there. LUSAS, which is used for bridges, lots of structural adapters here, Energy Plus, IES, TAS, all that good stuff. So BOM loves flow-based or visual programming. All of our user interface has been taken from the software that we already use to do visual programming. That's a nice way to interact with the code that's been built. So once you write a function within BOM, it automatically appears within Grasshopper, Excel, and Dynamo. You might be asking why Excel? Lots of people love Excel, and we believe in using the right tool for the right job. So if you look within Excel, it's better for more like data operations, and we'll see that through the demos here. But of course, Grasshopper and Dynamo being the flavor that we love within AEC for visual programming. So you'll see that everything has a lot of parity between the three interfaces. You can see here exactly what they look like within each of those three interfaces. We are open to expanding this to using other interfaces if there's something that comes up. Again, it would just be another toolkit. So if you take a look at what this actually looks like within BOM, we see we've got the adapter, the engine, and the object model. If we select an object, for example, we place that down on the canvas, it's just a blank object there. However, you're able to go in and actually explore, as we saw before, the many different objects that we've got within BOM. So you just right click, go to a particular toolkit name. In this case, let's say we're going to geometry. You can select a specific geometry representation here. In this case, we would select a mesh. We see that the component pops up here. However, you can also go through and just search for a component by name. You can also hit Control-Shift-B, and that allows you to search for anything within BOM. So that's another quick tip there. So Eric's going to be going through some examples of how we have utilized BOM.
Thanks, Kaylee. So just touching on a few ways that we use this as far as our workflows and how this affects the way that we describe objects and send objects to and from each other. First example we're looking at here, this is a pretty standardized workflow that we're using now on quite a few projects as far as looking at transdisciplinary design and what we call rapid prototyping. We're literally looking at how we rebrand this as not just rapid prototyping because we feel like that's not really the best phrase for it. So hopefully next time you see something like this, we'll have a zingier sounding word to describe it. But essentially, this is something that a lot of people in the AEC industry have been looking at, which is early on when we have something like a massing, how do we efficiently derive all the different bits and pieces that that massing leads to for each different discipline? So we've seen, it's pretty typical in our industry, we'll see Grasshopper scripts to take a massing and do X, Y, and Z in order to get windows out for facades or in order to get the mechanical routing for some kind of early calculations. Maybe you're going into Ladybug for those calculations. And rapid prototyping is how we use the BOM to just define all these things in a common framework where once we have that massing, we know that we can describe the building in all those different ways that diagram that Kaylee showed in the beginning is starting to touch on. And by doing that, we're able to really quickly connect all the different disciplines to their source of truth or to what they are deriving their information from, feed those through analysis, and then really quickly get answers back. So this means at early stage, we can get a wide range of designs and get all kinds of good information from an analysis standpoint on the key metrics for those designs for all the different disciplines involved. So this is one of the ways that we're leveraging the BOM to affect earlier design work at early stage, to get the right answers, to make the right decisions to ultimately lead to a better design down the road. And the BOM really is central to this as far as the way we describe these objects in the common language and the way that we then use interoperability to send those objects between different platforms or to analyze them to use engine methods to query them for key values, for example. Another option that we use the BOM quite a bit for, and that I think most people get a lot of value out of, is looking at things like generative modeling. So just if we need to create geometry, being able to create geometry from our primitive information into proper BOM information. These are data-rich objects. These aren't just flat geometry. So these data-rich objects then can be sent between different platforms that depend on that data. They also can be sent between, the analysis into something like Revit with all that data still maintained that obviously then feeds into things like documentation. It's just a really handy way for us to generate geometry with data that's critical to our workflows and that we can send between different software that depends on that data. And then expanding on that, here you can see a similar example to the last video, but with Excel. So simplifying workflows to be able to cater to different processes on different projects. In this case, using Excel to just enter in some key coordinates and quickly prototype out a multi-story building layout. So the one shown here is just a demo, but this is a really handy tool to have when you're early on with an architect and you want to explore different solutions. And maybe it's not even just a matter of they're giving you a bunch of different masses. You're having more of a dialogue of laying out the structure and the general massing in order to understand how that relates to structural performance, member sizes, things like that. So you can see in this example here, we're starting with just a few points that are entered into Excel, and from there generating all of our slabs, our typical shear wall layouts, running that through analysis, and then that can be fed to whatever analysis platform we prefer, and can also then be sent to somewhere like Revit. I think the key thing here too with the BOM is we're not tied to specific platforms. So we found, especially being a global practice with a lot of different regions, with a lot of different codes that they're required to design to, a lot of different software that's either kind of blackballed in certain areas or really preferred in certain areas. This flexibility to say we have the same model description and we can then just send it to whichever analysis we prefer and get the same consistent result out is really powerful for us. So, if we need to use ETABS, we can use ETABS. If we need to use Robot, we can use Robot. And we're not going through the process of like tweaking a bunch of information to make it robot ready. Since it's described in the BOM and the adapters handle those conversions in a consistent manner, we can consistently create that same analysis model in whichever platform we prefer. And also helps us to connect design to data. So here you can see an example of our data sets in the dropdown on the upper right. And these data sets let us curate ready-made libraries with all kinds of data, such as EPDs for life cycle assessment analysis, section sizes for steel design. We have all of our section sizes from AISC and our other standard section libraries. We also have curated data sets for other things like facade mullion properties, for example. So like what kind of different facade mullion profiles we're using. You can see the collection here. We're always trying to build up this data set. It's really powerful for us. This data set is kind of where the value of these workflows gets kind of amplified tenfold, because instead of creating a bunch of properties in the beginning, you're able to select from that curated dropdown of data that we know is essential to our workflows, and then feed that through to our BOM objects to populate them with rich properties. And then Kaylee mentioned earlier LCA Toolkit. So this is one of the toolkits that we're proudest of. I think Kaylee and I are also biased because we were both very involved in this toolkit, and I think it's at certain parts of our career been the thing we were like most excited about, or like held most dear to the work we were doing. So LCA Toolkit was part of the BOM, and this was a toolkit that was spun off initially as part of a kind of hack exercise, and from there became a formalized toolkit. It won the 2020 Innovation Award from the AIA, so this was last year, recognizing this kind of open source, forward-looking approach to LCA that makes it accessible, transparent, and also really flexible. And the key for why we use LCA Toolkit is the flexibility combined with the fact that we're not tied to a specific software or a specific way of defining things. We're able to take from any software, from analysis, from Revit, from Rhino, from an Excel spreadsheet of data. From any of those locations, we can consistently collect that information, and then through BOM objects fed through LCA Toolkit, get our critical values out. Currently, we're mostly using this for global warming potential calculations, but we've introduced recently phasing. So now we have full phasing beyond just our typical A cycles, or even beyond our typical A through D cycles, starting to look at how we account for things like design for deconstruction, reuse, things like that. And we're also looking at incorporating, if you've used Tally, you're familiar with all the different metrics it gives you beyond global warming potential. So we have those as well in the LCA Toolkit, and we're now looking at how we can start to consider those as well. But we've pretty much identified global warming potential, embodied carbon. That's the critical value that we need to improve immediately, especially since a lot of our work is structural, and structures is obviously a substantial contributor to that. And I would really encourage all of us in the room, I think from the intros, most of us are architects or engineers who have a pretty direct input into the design. So embodied carbon is really something that we should be working very hard and very diligently to minimize on our projects. And LCA Toolkit is, in our opinion at least, an exceptional tool for us to achieve that. And then last but not least, connection to web platforms as well. So a similar workflow here where we're just generating a building and sending it to different places. But in this case, connecting to web platforms. So you can see connection to Speckle and 3D Repo shown here. We've used the 3D Repo connection, for example, for combining. We have a toolkit that pulls from inspections and then can populate those as issues that are tracked in a database. And we've used a workflow where we send those to 3D Repo overlaid with a model that's synced up to 3D Repo as well. And by using the BOM, it lets us be really flexible in those workflows. We're also now looking at how we kind of leverage web-based platforms more going forward. So among other things, we're working now on support for Blazor and direct integration between Blazor and the BOM code base, which is also in C#. So really exciting development as far as getting us closer to direct web-based development. And also we're not really sure where that'll lead yet, but the fact that we can have our native BOM objects described in a web-friendly platform that's ready to deploy, we think there's a lot of potential there. So we're really excited to see what comes out of that as well. And then just reiterating 2 key URLs. If you want more information on the BOM, you'll see these links a lot, but bhbom.xyz is kind of our just homepage or splash page where you can go get the latest downloads for the installers. Those are updated on a quarterly basis. So every 3 months, you'll see a new installer. And then github.com/BOM, of course, if you want to see the code, or, for us, the best thing would be if you want to contribute to the code. If you go there, check out the repos. And we are always very eager to have external collaborators. So I know in the intros too, it was mentioned folks being interested in using the BOM, but also potentially collaborating, and we would love that. So if you are interested in collaborating, reach out, and we're always pretty happy to, if we have an external collaborator who wants to get involved with contributing to the code base, we'll go through the initial process, kind of walking through what the code, how you contribute, how the code's laid out, what's going on there, basically, because for us, it's huge that we have as many people involved as this as possible, and we don't want it to just be a Bro Happold coding exercise, because then it becomes an echo chamber. This is an AEC code base, the way we see it, and that's, we want as much external involvement as possible because of that. And with that, I'll hand it back to Kaylee.
Thanks, Eric. All right, so for the masterclass workflow, does anyone have questions about anything you saw so far?
Pretty awesome, by the way.
Thanks, Vincent.
I was just going to comment on the contribution. Just in my past experience, when my first attempts at contributing to an open source project, I always hit the wall of being completely lost in the project in the beginning, and I think that's a critical thing to invest in, is to have some sort of onboarding set of tools, sessions, recordings, whatnot. It can set the difference between a contributor jumping in versus just shying away and looking for another open source project that might have an easier price of entry, I guess. So I'm with the others here who have expressed interest in contributing, but I would also be interested not just in contributing, but also providing feedback to improve that onboarding process, since it would be my first exposure to the code, and not just the code, but also the documentation. I think that's even as important as getting your bearings on the code is contributing with the onboarding process.
Yeah, totally agree. And if you did want to give feedback as part of the onboarding process, that would be amazing, because honestly, that's part of what we're after, is getting more people involved and also understanding what'll help get, make it as easy as possible to get more people involved. So we've put a lot of effort into the documentation side to make sure that there's, your proper wiki pages with demos and stuff like that. But I think we by no means have mastered kind of bringing people on, onboarding for the open source contribution. So I'd be really excited to, to have you involved. And as noted, we kind of set time aside to get people familiar with what's going on, but also to get feedback to make sure that going forward, that's the smoothest process possible.
How do we reach out, by the way? Who do we talk to?
So since you're on this call, myself or Kaylee are great folks to reach out to. And you'll have our emails so that you can always reach out to us. We also have a Kaylee, is there still there's like a bomb email, right? I don't know
There
it off
is,
the top
there's
of my
a
head
Slack
though.
channel for
Yeah.
external individuals to get involved. The easiest way to get our attention is to raise an issue on GitHub. And then we were kind of forced to respond to that. So we've had a lot of people, especially for LCA Toolkit, just reach out by raising an issue and saying, hey, this is a little bit unclear to me. And then it starts a conversation. You can always reach out directly, like Eric said. There's the Slack channel for external folks to just reach out there. I think that's probably the three best means of getting involved. We've had individuals reach out specifically about creating an adapter. We have had some folks just create it on their own. So really lots of different forms there.
Cool.
Just one more question. Does BOM also encompass facade elements, or is it specifically structures?
Yes, wonderful question. So my current role at BH is Global Specialist Development Lead, so facades falls under that umbrella. We just recently had a internal hack where one of our hacks was a LOD 100 facade focused hack, looking at describing with BOM elements the entire facade of an early massing, and then from there calculating overall thermal performance using some internal data sets we had, and then also calculating cost, embodied carbon, a couple other metrics like that. So we do have facade elements. They are relative to some other parts of the BOM, somewhat new. So I think what would be huge is if that's if that's what you'd be looking at, it'd be really good too to get feedback on how how the object definitions we have right now suit your needs, and if there's anything that you feel like they need added or tweaked. Like, we're always really excited to get that kind of feedback. The nature of the code base is that it's pretty flexible. So if we realize we're missing, we need to add a property, for example, we can just add it. That's fine. So it would be really good to get your eyes on those. But we do have, fully functional facade elements that we've been using for some of our critical workflows already, especially for early design analysis. So yeah, those are there.
Anything else before we crack on? Cool. All right, so on to the meat of the session here. So it's 2 hours, 2.5 total. We'll be taking a couple of breaks in here since it's a lot to digest. We'll start by downloading everything, making sure that everyone has everything ready to roll before we get started. We will be spending the first hour on data and diffing. So like I mentioned, that was change control and use of our Excel UI as well as Grasshopper. And then Eric will be presenting on creation, interoperability, and analysis. The first portion more focused on rooms, the second portion more focused on structural elements. So again, back to this diagram that we love of the OM engine and adapters. The ones that we'll be using today for objects, we'll be using structural bars as well as rooms. And then engine methods, we'll be using the diffing engine as well as the LCA engine methods. And then for software, Rhino, Revit, SAP, and what we call file adapter, which is pushing JSON files around, which we found is the easiest method of getting quick interop between different platforms. So on the rapid prototyping slide where you saw the building kind of flashing back and forth, that was just using file adapter to push those JSONs around. So we'll be going through those specifically on this diagram. The first exercise we're going to go through is on Revit rooms. So editing their data as well as their geometry. So we'll start by pulling those objects from Revit. Two core BOM words you'll hear is pull and push and pull. That's how we kind of get things in and out of different software packages. So we'll start by pulling those in Grasshopper as well as Excel. We'll be pushing those BOM objects to JSON. using File Adapter. And we will show you an easier means of editing data. Excel toolkit, not that novel of a concept. Everyone has an Excel editor for Revit. Everyone has their favorite add-in. However, it's a nice little addition to BOM Facet here, as well as tracking the changes to data through Diffing Engine and tracking them to the geometry using Diffing Engine. So we'll show that in both Grasshopper and Excel. So this is the basic concept that we'll be going over first. And we love a workflow diagram. This is how we communicate best within BH, and I think globally everyone can relate to input, process, output. So you'll see that Eric and I both have these diagrams for the exercises we'll be going through. So this kind of explains where the data is moving around and what we'll be going through in the first portion of the exercise. But before we go ahead and get started with this, I just want to make sure that everyone downloaded BOM from the BOM.xyz site and downloaded all of the files off of the Google Drive path that Eric sent around in the chat. I guess first, who will be following along? I think that's a good starter question. Okay, Vincent, cool. Anybody else going to be directly following along?
What would you suggest?
I mean, the exercises are simple enough when we've set them up inside of all of the scripts that you should be able to follow along very easily. So I will just go ahead and flash up those locations again. So on the BOM.xyz site, you'll see that downloading the 4.3 beta installer, you'll have to have Rhino Red.
I think we might have lost Kaylee there. I'll pick up where she left off until she comes back. So when you install this, it'll plug into like Rhino and Revit. So just download the installer, get that installed, and then the Google Drive also, if you download all of the files in the Google Drive. That includes your scripts, so you'll see a few Grasshopper files, a couple Excel files, which will be your, basically those Excel files have the script logic contained with them then for reading in BOM objects and doing things with them. And then some base files as well, so you'll see like a base Revit model, Revit version 2020, by the way, that we can use for testing pushing objects to Revit, and we're going to be using that for the room interop as well. With that, it looks like Kaylee's back, so Kaylee, back to you.
Hey, I could hear you the whole time. Thanks for picking up. So in terms of following along, does everyone feel a little bit more comfortable with that?
Yeah, I think I'm going to try following along,
Cool.
at least initially. Quick question on the Revit version there, Eric or Kaylee. You said Revit 2020, and I do have that version, but I'm wondering with like really subtle differences in the APIs and stuff, does it auto-detect what version Revit file it's connected to or pulled on, depending on the plugins, I'm guessing? Or I'm just curious more.
So we've set it up so that we have specific deployables for each Revit version. So it's fully supported for, I believe, 2018 through 22 at the moment. But yeah, essentially you don't have to worry about which version you're pushing to. Revit Toolkit will take care of that. So no matter what, you know, if you're pushing to 2019 or 2021, that doesn't change your script at all. It doesn't change anything about what you're doing. You just, when you do the push, if you're connecting to a 2019 version, it'll push to 2019. If you're doing 21, it'll connect to 21. And those are, each of those DLLs are essentially referring to the specific API of that version.
Perfect, sounds good.
Yeah.
You won't notice any changes to anything based on using a different Revit version. It all looks the same. But the adapter was just updated to support 2022 as well.
Perfect.
Okay. I think we'll go ahead and start off rooms. I'm going to keep referring back to this diagram as we go along. So we're going to start off with those rooms. And the first thing we're going to do is use that 100 script to pull the original Revit file and push that to JSON using the file adapter. All right, so we have our test model that we love to use for different things. So we've got, just to be sure I'm using the same file as all of you. So we've got 100 Grasshopper script here for pulling rooms from Revit and pushing JSON. So I'm going to open up Rhino, Grasshopper. All right, so I'm going to go to open that file. I love talking myself, so feel free to interrupt me. Let's open that up. All right. So you can see here that we've got our little heading here to pull rooms from Revit, push them to JSON. It's created using BOM version 4.3, which all of you should have downloaded from the BOM.xyz site. We can see first thing on the page here is that we've got our Revit adapter set up. That's where we're going to be pulling from. So of course, that's where we start off. You can see that there is a Revit settings portion. You can set this up to look however you want. There are different discipline kind of orientations for that if you needed to use it. I hardly ever use that function. Mostly just telling that specific adapter, which comes from up here. So if you go to this little plug button for create adapter, you'd be able to pull that down. Right click, just like you did in all the other videos, select an item. You can see all of the open source adapters to different software packages here. You can come over to Revit adapter and place that component down. We already did that for you ahead of time. So I'm going to delete that component. We can see that if we're looking at the pull, which is this component up here under the adapter as well, with the little arrow, this pull component is saying which adapter are you using, which software are you pulling from. Request meaning what are you trying to pull. The pull type can be specified again for that specific thing. Action configs are used for different adapters as well. There are some that are specific to different adapters. And then active, should I be pulling or not? So we'll see that that's already set up again here. So we've got our adapter plugged in from Revit. You'll see lots of these little repeater things if you're not a frequent Grasshopper user. If you just double click and you type in BOM object, you'll see that those pop up here. We like to use these little containers for internalizing objects so that we can pass scripts between each other without having to reopen up Revit or SAP or wherever you're getting objects from. So you'll see lots of those floating around on the page. Also just a workflow of keeping your script really tidy. It's always easier to work together if you're being clean. So the specific request that we're doing here is over in this area. In this case, we're telling it to pull all of the room objects, so filter by BOM type, as well as the level that they should be coming from. You don't have to set it up this specifically, but this is just showing that you can use logical and types of requests to pull only specific items rather than eating the elephant of 5,000 rooms within your project. You can break it down a little bit. You can also filter by selection, so just selecting a couple of things. You can also just go ahead and just plug this type right in here to the request. So types are probably the easiest way to work with in BOM. So you could just plug that in there, but we'll keep it as it is here for now. So you see that request is set up there. There is no pull type specified for this, which is perfectly fine. You don't have to have that. We did set a pull config option. So these are kind of neat because they allow you to have different permutations of visibility of things. So you can choose a specific discipline permutation of that, including closed work sets, including nested elements. You can also look at the geometry in different ways if you want to. So you can pull edges, surfaces, meshes, anything you really want. It supports lots of the different objects within Revit. So that will allow those to be visible within Rhino. You can also, if you didn't set this, you'd be able to see like the perimeters of the rooms. However, pulling surfaces lets you see the whole thing in 3D in the Rhino space, not the Revit space. So we see that that config is set up. And then last but not least, the active component, which allows us to pull those objects here. So without further ado, we are going to just go ahead and pull those objects. I'm going to set this from false to true. And this is using the Boolean toggle function within Grasshopper. All right, so what is it saying to me? It is saying, failed to connect to Revit. Whoops, Kaylee forgot the first step here. If you go over to BOM within Revit, you need to activate it. So I did that on purpose, obviously. So I'm going to go to the BOM tab in my Revit screen here and click Activate. Since we are all sadists and love having tons of different Revit versions open, you can have the option of updating ports here. If you have 10 versions of Revit open, which probably drives your IT department nuts with licenses, you can set the ports on here. If you just have one version open, don't worry about it, or just one that's active. But if you're pulling and pushing between different Revit models, you can set ports on them. So don't worry about that right now, since these are the default port numbers. So here we've got that activated now. I'm just going to set that back to false and then true, and it should pull my Revit rooms across. Whoops, I forgot to change it. Any questions on pulling? All right. So now,
Mine still says failed.
just change it from false to true again.
Okay.
And let me know if it still has issues.
Got it.
Cool.
Perfect.
All right, so we see on the result side of the poll, if you hover over the objects, we see that we've got 18 objects. These are all defined as, I'm going to put a little panel here so we can see them, bh.om.architecture.elements.room. That's because that's the type that we set up over here. So that is the way that BOM is viewing those rooms as it pulled it. You could also pull them as environment spaces if you wanted to. Those have an interchangeable language, but a disciplinary spin on the way the object was defined. So the default here is the architecture elements room. So we see we've got a couple of little containers sitting here. This is the one that I'm going to drop these room objects into. So I'm going to grab from the objects on the pull and drop that into the BOM rooms from Revit revision 1. So now that I've got these in here, I can also use my handy dandy internalize function and actually keep them inside of the Grasshopper script if I wanted to, so you never have to open up this Revit model again. You can right click and internalize data. It's a nice way to pass scripts between people, like I said, so you don't have to go ahead and open up every model. So we've got those sitting inside of this little container now. We see that those are connected over here to our file adapter push, which is going to push that JSON file across. Do we have any questions before we explore the push?
So essentially, this is just pulling data and then turning them into JSON.
This part of the workflow is, yeah.
Got it.
So the overall workflow, if we go back to our diagram here, is that what we're going to do is we're going to make some changes to these rooms. We're going to change some data about them. We're going to change some geometry. And then we're going to use our diffing engine to be able to figure out what those differences are. Eric's actually going to pick those up and modify his roof structure as a result later. But within this workflow, we're just going to show how you can push those JSONs along and kind of keep track of your different permutations of a model. So workflow we really try to get into at BH is keeping track of your different files. So if you want to say the architect gave me a model on day 1, and then they gave me a model on day 30, and I haven't updated my spaces since then, and I only want to update the ones that have changed, how do I know what to look at? So this allows you to basically diff or find the differences between those different models and look at the data that's changed, look at the geometry that's changed, and then you can decide how to move forward with that. Another workflow we use this for is our electrical engineers love chasing the mechanical people around for the loads on their mechanical equipment. And they usually get stuck with doing that 2 weeks before the deadline. So they'll say, okay, I did this 2 months ago. I want to know where to look very specifically to see what has changed. So you grab the mechanical equipment from 2 months ago, grab it from today, and you can see the differences. So lots of different applicable workflows for this, but it all starts with the JSON of the older version versus the newer version. You could also have the Revit model open for the older one, Revit model open for the newer one. But storing a JSON is a pretty nimble way of working.
That's cool.
Can you disable that automatic feature that when you draw a wire or you start drawing a wire, it automatically, that menu shows up?
Yeah.
With like BOM options? Yeah.
You don't like that?
It's kind of, sometimes when I'm not using BOM, it's kind of annoying every time like I make a mistake of like, letting go and then this pops up. It's kind of annoying, but like it would be cool if you could like enable and disable it. I mean, I understand it's useful, right, as a feature when you're working with BOM specifically at the moment, but
yeah, I think that's amazing feedback, honestly, because it's something that would be easy to implement, and we've never really thought about it, but I could totally see how that would be annoying. So I think we'll track that through. One thing that I think we actually wanted to make sure we mentioned as part of this session, and this is probably the best time to do it, is that BOM is very much a living code base that we're constantly, it's how we deliver our work. So it's not just a code base that we've like finished and now we're just maintaining. Like it's alive, and we have a development process to account for things like this. So we will essentially, after this call, an issue will be added to Grasshopper Toolkit to note this, and I would be shocked if within a couple weeks it hasn't already been fixed, so that then if you're doing a live build, you have that feature. Because I think just straight away, the second you said it, I was like, oh yeah, like that could get annoying. We like it because we're always using BOM stuff, but I could totally see how having it as a parallel install with other stuff when you're not just using it would be annoying. So we'll track that through then. That's really handy feedback.
Awesome, thanks. And just one last question for now. Updating BOM versions, is it always through an installer, or is there like an update component updater or something?
Installer for now, update component to follow, but as of now, it's just installers. Each installer essentially will either do your like reinstall, uninstall, update. But we do live build too. So since it is open source, you can always do live build if you want to do like latest and greatest, or if you want to do your own development on top of it. But otherwise, yeah, just installers for now.
Cool. The feature that was referred to there by Patrick is the if you pull off a wire on something like the adapter here, there is IntelliSense, which basically gives you the most commonly used things here. So I can type in Revit and find that particular adapter. I actually didn't realize, because I use BOM all the time, that pervaded through all the other components there. So again, very good feedback. Eric or I will raise an issue on that and get that built in the next week or so, probably. Any other questions before we move to file adapter?
Can I ask, where are the JSON file stored, or where are we pushing this to? Or
wherever you want.
Okay.
So in here you'll see my GitHub folder, which is probably not the best place for it, but that's where I stick all my stuff, like a desktop. So you can go ahead and change that file path. You can see here that we've got those objects. Looks very similar to the, is my internet cutting out again, Eric? Can you hear me?
Yeah, it did for a second there, but you're
Okay.
Good now.
Sorry.
If it happens again, we might maybe just stop doing your video, but for now, I think you're good.
Fair. Okay, so the push looks very similar to the pull. You're telling things where to go. So first the adapter, then the objects that you want to push. So dissimilar from requesting what to pull, you're telling it what to push with the objects. Then the tag for those objects, if you needed it, a push type is usually a pretty fundamental thing to do. So when you're pushing to Revit, you usually want to do update only. You can see here that it's usual kind of CRUD language of creating, updating, deleting. For JSONs, delete and then create is usually the default behavior. You don't want to keep rewriting over those objects that you're pushing. You usually want to just delete then create for a particular file name. And then the active again for this, in this case, setting it to false, so we're not just automatically pushing that JSON. So for the adapter here, we see that we've got the file adapter. So this is the magic sauce for pushing JSONs within BOM. You've got the folder path here. So I just have a little panel here describing my GitHub folder where I was pushing these JSONs to. So feel free to, well, or you have to actually, paste your own link there. So any kind of file you have within maybe I'll push them to here. Just go ahead, double click and paste a particular folder there. Go ahead and change the one down here at the same time. And then the file name that you give it is going to be the file name for the JSON that you push. So room objects revision 1.
Cool. It's all clear.
So if we're feeling good about this, we can go ahead and change this to true, and then we should change it back to false so that it remains closed. You'll learn pretty quickly to keep those shut off until you need them, or else you'll keep pushing and pulling things. Live updating, it's kind of like using manual mode in Dynamo. So if I go back over to that folder, I see that I've got my room objects underscore revision 1 JSON file sitting there now. So those are actually room BOM objects that we have pushed along. So the BHOM architecture elements room objects. All right, any questions before we move on to an Excel-based workflow?
My script is not visualizing rooms in Rhino. And so like this get all fragments component is not passing anything through. At least for me, I don't know if there's something I should change.
So it might be, is it your red mode, green mode?
No, so Kaylee, that's because of the pull surfaces.
Mm-hmm.
So Kaylee, if you go full screen here on Grasshopper.
Yep.
And go up to your fragments. I would suspect you actually are getting fragments. Are those coming from the?
Let me change this to everyone here. This was set to false by
Yeah,
default.
exactly. Yeah, that's where we're going eventually. So this is a good illustration of the pull config. So in this case, the pull config, when the pull surfaces is set to false, is saying don't pull over the surfaces. But then that visualization was basically saying grab the fragment that corresponds to the Revit surfaces that have been pulled.
Mm-hmm.
So it was going red just because that was set to false. So the fragment essentially wasn't being found, so then nothing was being shown.
Okay, now it's working. Thanks.
Cool.
Yeah. And that's something we use quite a lot actually, is the ability to really like refine what we're pulling from Revit geometrically. We want to pull things as standardized objects, but sometimes, you know, Revit obviously tends to be what everyone's looking at geometrically, what everyone's modeling to. So it lets us pull, if we have like, for example, a really gnarly nested window family for a facade, rather than just pull that as our default facade object, it gives us flexibility to pull all that geometry too, and then to do manipulations of that geometry as required downstream. So just really a handy tool to use if you're doing Revit-based workflows, is that the geometry part of the pull config, being able to refine that.
Yeah, it's interesting. I didn't get an error. I did not know that was a toggle there, but after turning it to true, I do see the surfaces in Rhino now.
Perfect.
All right.
When sorry. When I toggled the push to true, I'm not getting anything showing up in my folder. So I reset the link to a folder on my desktop like you did, but I'm not seeing anything. Any suggestions for where to look?
Did you pull your objects into this container here first?
Yes. No. Thanks.
That'll do it. It's because I internalized it, it wasn't showing the exact wire when I was doing it, so I could always open that back up and pull that like that.
Oh, actually, sorry, it wasn't that. It's still, I've now pulled it over and it's still not showing up when I toggle the true back and forth.
Okay, so you've got your objects going from here into
Yep.
here.
Yep.
Your adapter set up properly. You have a full file path.
Yes. Yep.
Okay. And then delete, then create. And then
Yep.
this is going from false to true.
Yep.
Do you maybe want to screen share? I don't know if that's possible.
Well, before we do that, can you try just skipping the relativized user path method here?
Yeah, I can go.
It's possible that it's some kind of environment naming issue. So if you just skip that, is it working or is it still not working? It's typically
Still nothing.
okay. Because typically when if it wasn't working, when you toggle to true, the push is not turning red though, right? You're not getting in there.
Correct. Yeah, there's a little gray bubble that shows up, replacing entire context of file. Oh, but there was no file there to begin with. So is the replace causing an issue?
It shouldn't be. No, when you hover over the objects, the object input of the push, can you just make sure that there are objects going through? Yeah, the way Kaylee's doing right now.
There are, yes.
Yeah.
That's okay. If it's not happening to anyone else, I can just follow along.
Yeah, if you don't mind, maybe just try switching the file path to like a.
Sure.
I was going to say put down a new push component. If all else fails, reconnect all of these bits and see if it works. It should be fine. That way you're at least kind of by rote checking that everything is filled in. And let us know if that helps to solve it.
Thanks.
Quick question. Sorry, I missed the whole visualizing services portion of this. I'm not seeing anything in my Rhino.
So if you
come over here.
Right. I had it set it to true. And then
you're going to re-pull. So you're going to go
I see.
false to true up here. And then you should be good. Let me see. I think we specifically didn't want to, Eric, because we were getting the fragments piece yesterday. You'll see that this will come through on the diff when you do that by the fragments, but it's okay. We'll do it with both so that you'll see it both times.
Yeah.
Because the surfaces are then a part of that object as they come through, which is kind of interesting. Vincent, were you able to see them this time?
I think so.
Yeah, so we see those pop up back here.
I'm only seeing like a bunch of lines.
That's probably that you're pulling the perimeters of the rooms then rather than the surfaces. Yeah, so I think I had to redo the false true twice up here to get these to come through. So just try this again on the active and you should be able to get these to pop up.
What's the reason to sort of toggle back and forth true false? Is it just calling whatever function that it's underneath to run again?
Yeah, exactly. So just if you like change a config setting and you don't have the adapter set to run, then you just want to rerun it then.
Got it.
Did that work?
No, but it's okay. I can try to troubleshoot later. Yeah, it's just pulling all of the outlines, but none of the surfaces. That's okay. We can, if we're running out of time, we can move on.
Yeah, if we want to go back to it at the end, we could do that.
Sure.
Cool.
If it helps in debugging, my pull edges only does not work, but my pull surfaces does work. So with the pull edges, would you expect just to see edges and not the entire surface, right? Yeah. So I'm seeing the opposite of what the other person is saying. So my pull surfaces do work, but my pull edges for some reason don't want to come in when I toggle. Just a side note. We can continue. Sorry.
Good to note that. No, if you, Kaylee, if you just change plug the true into pull edges here, yeah.
Mhm.
And then, yeah, so
And then
you're
take
open
out the
up.
pull surfaces. I took out the pull surfaces. I'm assuming.
No, Kaylee, change it to true. Your Revit adapter, just leave it to true. So we're connected, yeah. And then get rid of pull surfaces. Leave it true, leave it true, leave it true. And then let's go up top. So I just want to highlight why this is happening. Kaylee, if you go up to the top. So where we're visualizing, in this case, we're saying get all fragments, and then we're getting the surfaces. So if we hover over edges there, yeah, just Kaylee, if you just hover over it. So now that we're getting edges, you would just need to update what you're plugging in, because essentially what we're getting is a fragment with all of that geometry. So it contains meshes, surface, and edges, any option of those based on the config that you set. So here you would just need to update it to visualize those edges instead of the surfaces.
Yep, makes
So
complete sense.
Kaylee, if you plug that into a curve component real quick, just so we can see it. Yeah, and the edges, yeah, there we go. So now we can see that by changing the config, we're just getting the edges of elements. Sometimes this is useful if we're doing things like trying to just extract certain floor information or things where we don't necessarily need the surfaces. We tend to use the different levels of like geometry config and definition helps us keep files light so that we're only keeping the information that we need, but also lets us, access any of that geometry if we do need it. Sorry, Kaylee, back to you.
No, you're good. Vincent, any luck on your end in getting them across?
I think I wasn't seeing anything at all, and then I was actually just I just turn on the preview of the pull from Revit. That's what enables me to see the edges. But then I tried it again by turning on the preview without using your preview sort of materials, and then somehow Rhino crashed. So restarting. That's okay. It happens.
All right, we will trudge on then. All right, so back to the workflow diagram. So we've managed to pull the original file and push the JSON here. The next thing we're going to do is the 101 script for BOM in Excel. So if I go to my downloads folder here, it is the 101 file. Go ahead and open that up in Excel. Okay, so we see that we have a blank sheet here with all those bits filled in to some extent. We're going to see some little oddities here. So this was filled in initially with the adapter, the request, and the pull. Since I'm using a different installer, we see that these defaulted a little bit, but we'll see that the same interface appears here with the engine, the adapter, and the OM. In this case, what we want to do is put in a Revit adapter. We're going to be pulling directly from Revit because we're going to be making some options to that Revit object. Actually, just going to come back here and make sure that's false. All right, so in Excel land, I'm going to go to Create Adapter, Revit Adapter here. We see by doing this, we started to kind of click things into place. So in Excel, when you're dealing with the formula structure here, you should see some helper text pop up. Mine is on my other window, unfortunately. But the helper text will basically guide you through each of those inputs like on a node. So if you want to skip something, you just use a comma. So in this case, I'm skipping over the Revit settings and going right to the active component here and closing that up with a parentheses and hitting enter. I'm going to change this to false just to be safe with my workflow here on both of these. The request that we're going to set is again a room type object. In this case, we're just going to do the really quick version of it. So Control-Shift-B works exactly the same inside of Excel. So if you Control-Shift-B and I look for room, I'm going to see that this little T for type with the BHOM architecture elements room is the one that we want. So if I just hit enter, I should now see that my pull is set up exactly the same way that it would be in Grasshopper land, with first being the adapter that you put in, second being the request that you put in, third being the pull type, action config, and then the active here. So now that that's all set up, close the parentheses, hit enter. I'm going to change that activate pull to being true. And we see that our room objects magically appeared over here. This is taking this actual list of objects and expanding it down this side. So you can do that through a query reflection list, or you can do the expand list up here to get these different objects to appear down the side. So we see that we've got all of our room objects over here. Now what we're going to be doing is getting the properties out of those rooms. So you can imagine that using Excel would be very handy for someone who wanted to take a look at your Revit objects, maybe who doesn't love Revit. If they want to modify like a schedule or something, you can pull them into this interface and then push them back out with the modified data. Lots of good uses for Excel, mostly data. Eric's example of creating a model in there, probably not the best use for creating something in Excel, but you can. Doesn't mean you should. So here what we're going to do, you can see that the query adapters.revit.get Revit parameter value is the function we're going to use here. Our Revit Toolkit wiki is awesome. The guy who works on it, Pavel Baran in our Warsaw office, put a lot of effort into the documentation there. As we know, Revit is a bit of a language of its own. So normally you'd be doing just get properties from basic BOM objects, but in this case, we're going to be doing a very specific query engine method for getting Revit parameters. So if you hit Control-Shift-B and then look up get Revit parameter, you'll see that that is fairly close to the top. So in this case, we're going to be doing that bottom query with the little looking glass Inspector Gadget icon there. bh.engine.adapters.revit.query.get Revit parameter value for a BOM object, and then its parameter name. So if I click that in there and I click the BOM object, we see everything magically reappeared. Thank you. I'm just going to show you how I would do this here. So clicking the BOM object, lock that guy into place, and then the parameter name, I just stuck those up here, and I'll make sure that it always refers to that by locking it in and closing that up. So you do see that the rest of the functions reappeared when I triggered that command happening there. So we've got all of the parameter names of those Revit rooms. Nice little list there. The number of the room is another property that we've pulled across, again, using that same functionality. The occupancy is something that we pulled across as well. And now let's say that what we wanted to do was change that occupancy to a different value. Feel free to type these in to be whatever you want them to be. Just made up some different values here, so we'll be able to see that these have changed. Let's say these were based on a chair count at first, and then you're actually updating them to what IBC says they should be. Now what we'll do is actually change that object. So the difference with BOM versus something like Grasshopper or Dynamo is when you set a property on something, you're actually changing the object. The object sits on the other side of it, not the property. So when we do this, we're going to do a modify command. We see adapters.revit.set Revit parameter. So again, we'll see if I Control-Shift-B here and type in set Revit parameter. I can do that by the BOM object, the string for the parameter name, and then the object value that you want to set there. So in this case, we see that those all magically reappeared, but I'll show you how we walk through. There is the object, comma, the parameter name that I want to set is actually this occupancy up here, not a new parameter called occupancy new. Close that up, and then the value associated with it is going to be from this cell under here, and I can close that up. And we see that the result of this is actually the room object with that new value for occupancy set on the side of it. So we can see that that's the structure for each of these moving forward. So this is your list of new objects, well, the same object with some new data on it, that has moved along here. Any questions about general use of BOM, Excel, anything like that?
Sorry, I'm not familiar with Excel. I didn't know you can call functions from Excel. When I do Control-Shift-B, I'm not seeing the pop-up or the search coming up.
You might have to activate the BOM add-in first. Do you see the BOM tab up top?
In Excel,
Yeah.
I don't.
Okay, so I think you just have to activate the add-in first.
Do you go to File Options, Eric?
Yeah,
Add-ins.
Got it.
and then, yeah,
Get
so
that
here you
activated.
should see that it's, if you scroll to the bottom, you probably see it as a disabled application. So we just by default disabled it so that people didn't have an install and then suddenly have it in Excel when they didn't want it. So that this one is one where you do have that kind of optional active or inactive. So you're just set to active and that should do it.
Cool.
A quick question. Could I change multiple parameters at the same time?
Yeah, so if you, when we did that Control-Shift-B for set Revit parameter again, you'll see that there is a list option here for the list of parameter names and then a list of values. This is how we do, usually what we do is take the values from something like IES and push all that data into our Revit spaces. That requires a long list of parameters, a long list of values. So this is a nice little function for manipulating lots of data at the same time.
Perfect. Thank you.
All right. So now, any other questions before we go ahead and push these back to Revit? Cool. All right. So now what we're going to do is we'll see that the push is set up the same way that it was in Grasshopper, but it's just through Excel this time. So we see that we've got our push component here, which you can grab from right here. And it is set up to have the adapter for setup, the list of objects that it's taking in right here. We skipped over the tag portion here. We've got the push type. In this case, update only. Very, very important. The default that you would have there sometimes is delete then create. I think it might be update only in Revit Adapter specifically, but I always want to make sure that you set that because you'll be really surprised when you delete everything and recreate it. So you may not want to do that. So in this case, it's a drop down in Excel as well. Same thing that you would see inside of Grasshopper. And then we've got our action config active, and then including output names, some other little bits that are in the Excel push. So that push, once we activate it, should actually make that change in Revit. What we will do to make that look a little real over here is we're going to open up a Revit schedule, and we should see these numbers modify when we push them through. So I'm going to make this a little bit smaller so that we can see over here. If I change this to true, we should see specifically, what was this first room? Men's toilet occupancy should be 12. This one should change to 12. All right. There we go. So we had our updates to Revit properties happen over in Revit land. If you didn't like that that happened, you can always undo the fact that the BOM push happened over here. Same way as running any other script, you have that capability. Any questions about Excel stuff? For the sake of a metric here, about 20% of BOM UI triggers are in Excel. So Grasshopper is by far the preferred interface. Dynamo falling way behind with like 2%. I think using Grasshopper, we all probably in this room know that that's a bit better for a geometrical operation. So that tends to be our heaviest UI within BOM.
Do you have any examples on why Excel gets used for what types of problems Excel is used to solve?
Sure. I use it very frequently because in MEP, you tend to have Revit and Excel being your main workhorses. Like I'd say 90% of your work is done between those two platforms. So schedule editing, even doing things like lifecycle assessment, if you're able to do that for objects within the Excel interface where you're keeping track of environmental product declarations with the amount of embodied carbon and then your object kind of side by side. Some people prefer that method. Being able to do pushes of data in large quantities. So like I mentioned, if you have an IES model that ran your energy loads and I want to push that back to my Revit spaces, I usually do that within Excel's interface. Eric, do you have other examples of what you use it for?
Yeah, so in specialists, it gets a lot of play as well, and that's because they tend to have calculation spreadsheets. So you'll have like acoustic calculation spreadsheets, for example, that just by default are set up with all kinds of sophisticated formulas to take a room layout and translate that into things like reverb calculations. So what our acoustics team is doing now is that they have in their Excel a live link to the Revit data. They feed that through their calculation. So essentially you have your sheet, it pulls in all this data that you'd see here that goes into that calculation. And then from there, they're able to spit out the, add a parameter to the room that says what the reverb of the room is, for example. So it gets a lot of usage in workflows like that, where we don't need to go into external analysis software, where it's more just, using some kind of Excel formula or Excel logic to take something in and spit something out.
Thanks.
Or even early stage design for spaces for MEP, setting up like design criteria for an LOD 100, like basis of design report, where you're saying I have this space type and then I have all these different criteria for lighting load, people load, all of those things are set up as data sets. So you can set up a really nice template that once you do have a Revit model and you assign those space types, you can just push all that data through. So it's usually where we start as well, when you don't have something like Revit to push to, especially for an analytical type of problem.
Hopefully this is not a dumb question, but do you always need Revit to be open to, collect maybe that information and push it back?
So for collecting the information, what you could do if we're talking about the situation where someone doesn't want to open Revit, you can always internalize your data inside of here. So you can pass a JSON, you could always pull from file adapter, and then you'll have to have Revit open if you want to push it back in. But you can work with JSONs in between, which is a way that we sometimes work if you're passing information around.
Thanks.
But again, you'd want to be careful with workflow and making sure that other people weren't updating that at the same time.
Exactly.
Just another real world example of that is our lighting team tends to do that, where they have some folks who are Revit savvy and want to open a Revit model, and then some who will never open a Revit model in their life, but who want to edit a fixture schedule. So they'll use an intermediary JSON where they pull all the critical Revit information for lighting. They then, in a spreadsheet, can interact with that JSON data to add in whatever data they need for the fixture schedule. And then somebody else who's using Revit is the one who actually then brings that back in. But that way they're all, able to feed into that workflow in a nice way.
Can you push from Revit? Like, can you create the JSON without opening Excel or Grasshopper or Dynamo?
No.
One wonderful question. It is in the pipeline.
Okay.
We're looking at a couple key.
I was going to say, we just had a hack last week where we were talking about diffing as a concept within Revit. And I was like, guys, not everybody wants to open up, Excel or Grasshopper every time they need to push a JSON, but it's so valuable to be able to see the differences in objects in a more agile way.
Yep.
So we do have some functions where they're kind of buttons within Revit that you can press. So we did run a prototype of being able to do that just
cool.
within the Revit interface, so that you can get push a JSON out, and you kind of choose the file that it goes to, and then you select 2 files for the diff so that you can actually like visualize it in different colors just in Revit.
Mhm.
So take back, we do have an option for that.
Cool.
But early days on exploring exactly how that would work. But I mean, Pavel put the prototype together in like 2 hours, and it worked really great.
Awesome.
I have a small issues with the add-in. I don't think Excel is able to run when I enable the add-in. Then it's telling me to disable it.
If you try, can you just try closing Excel and reopening? And then
I
when you
did.
do a fresh open, it gives you,
Excel is running into problems with the BOM add-in 64.xll. If this keeps happening, disable add-in and check for available updates. And then I don't disable it, and then I don't think I see it in Excel.
okay, that might be, it might be a DLL clash. That's the first thing that pops into my mind. We can do like a troubleshooting catch up with you to take a look at this. I really want to make sure this stuff's working for you since you're following along, and you know, we want to make sure it's all set up right. So I'd be happy to take a look at that with you just to figure out what exactly is going wrong there. This is the last bit with like the Excel stuff specifically though, so I think for now at least we can hop back to Grasshopper land, and that way you'll be able to follow along for the rest. But yeah, we'll take a look at that.
Cool, thanks.
Yeah, of course.
Cool. All right, so back in Revit land, we're going to take this wall and shove it up a little bit just to make a geometry change to make Eric's life nice and difficult for later. So we'll shift some geometry in here too, just so that we get the diff across both geometry and data. All right, so we're going to go back to our first Grasshopper script, back to the 100 script that we had open over here. Now what we're going to do is, I'm going to set that to false so that I'm not pulling any of those edges again. What I'm going to do this time is, I've got this guy set to false, so we're all good. We're going to pull those Revit rooms again, but this time we're going to put them to a different JSON file so that we can diff between the first original set of Revit model rooms and then the second set with the geometry shifts and the data shifts. So here I'm going to set this from false to true. We see that we've got our 18 objects again. I'm going to push those down here to this container. That container is now connected over here and should be pushing to this JSON file name. I have the same path up here. So if I change this from false to true, we should see that those pull into, or sorry, push into a JSON file. So now if I go to my downloads folder, see I've got revision 2 in there as well. I think I pulled edges in my first one because this file is a little bit bigger. So we're going to see that that's a part of the diff. It's okay. So now that we've got our 2 files, we're going to move on to the point here. So we've done these 4 bits. We're going to move on to the point where we're doing diffing in Grasshopper, and we're also going to do it in Excel so that you can see the 2. We're obviously going to start over. I did not name these in the right order. We're going to start in Grasshopper just so you can see the component because it's obviously easier than flying blind in Excel. So if we open up script 103 in Grasshopper, I'm going to go ahead and do that. 103 diff rooms. We'll get that open in Grasshopper. All right, this fun script we got set up here. So this first bit up here is showing that you could pull directly from Revit if you wanted to. Like let's say that live version of the model is today's version of the model, your current objects. You could do that. The other option is just to pull those directly from your file adapter from the JSON files, which is how we've got it set up here. But we left that up there for agility in your own workflows after this. So that first bit that we're going to do is I'm going to change my file path here. And this time we're pulling from file adapter. Oh, whoops. Just gotta set those to false. And set that one here. So we see that we've got our pull from file adapter. Nothing else required here, just the adapter and the active. How great is that? So for the file adapter, we've got the folder, the file name. Make sure that you've named these the same things here so it knows what it's pulling. And then it will be set to true here to pull those objects across. Cool, I've got 18 rooms. Again, 18 rooms here. Got a little container here. Popping those up to this object. Same thing with this one. So this is one of the more fun engine methods that we've created. This was a UK grant, a project between Speckle 3D Repo and BOM to basically limit the amount of data that we're passing. If you think about the fact that we exchange these gigantic Revit models on a daily basis across the whole world, really what we should be passing is the changes, the delta between them. So that's how the diffing engine was created. So what this engine method for a diff is asking you is it's saying, what are your past objects? What are your current objects? What is the fragment type that you're looking at? In this case, it's Revit identifiers. The fragment ID property, persistent ID, element ID also works here. Unique ID is one that's being implemented for this as well. You can also set up a unique hash if you want to get fancy and just diff specific stuff. And then there's also a config where you can do different kind of permutations of what exactly you're looking at in terms of changes. Sometimes you just might want to look at data. Other times maybe you just want to look at geometry or location. So it leaves it pretty open-ended in terms of what you can diff. So in this case, what we're doing is we're passing along that first set of Revit objects, a second set of Revit objects here, our fragment type. And then, since I was already plugged in, what you should see over here, if you explode this, a concept we somehow did not explore yet, but it's my favorite thing. If you go to the engine methods and this little explode component, that basically allows you to see anything kind of in more verbose format of what exactly it is. You can also use this explode on the room objects and you could see their properties. You use that all the time because you're always looking at properties of things. So we see that the room object was comprised of perimeter, location, name, fragments, all that good stuff. So that was an explosion over here of that diff. So this is the diff engine method. The explosion of it has the added objects, the removed objects, the modified objects, things that did not change, the properties that changed when things were modified, and then the config setup here. So we can see that we didn't add anything, which we know that that's true. We didn't remove anything. We did modify 8 objects, either by geometry or data. And objects that did not change, there were 10 of them that didn't change at all. So if we start to look at the modified properties per object, again, just an explosion of the other one. Here we've got our property names, occupancy for the first 2, and then perimeter curves for some of the others because we did shift that wall in the north. So you can see that kind of in a very, long list format if you wanted to over here. Some workflows I've used this for, like I mentioned, seeing differences in mechanical equipment over time, seeing differences in architectural rooms, seeing plumbing fixtures that the architect has added, because that has lots of pains for the public health engineers over here. Lighting designer changes, lots of being able to do this. I know you could do it in BIM 360 as well, but this allows you to actually do something with the objects. So you could add this into a workflow for day 2 things where you're saying, I know I placed all these things, but now make these modifications based on changes. So like I mentioned, Pavel set up a little tool for us to be able to visualize them in red, green, and yellow inside of Revit. Bits like that, pretty, like standard workflows that you would imagine that you probably already have scripts for, but this is just doing it all at once with one little nimble engine method. So now that
And I
we
think
see,
sorry, Kaylee, I just wanted to note on that too. The huge thing is what you mentioned with building it into workflows. So it's not just identifying diffs, but it's reacting to them. So it's really cool when you get to the point of you don't just find out what changed, but you can actually codify what process you do based on things changing and how they're changing. So I think there's a lot of potential there that we're just starting to explore now within BH, and hopefully others are exploring as well.
any thoughts on this? I'm going to show it also in Excel, which, as you can imagine, setting this up in Excel looks a little more obtuse, but when we now know what it looks like over here, it should be a little bit easier to follow. Any questions? Cool. All right, so we'll open up that last script for the 100 series, which is diffing rooms in Excel. It's 102. So if we go ahead and open that up. We can see here, this might disappear again on me once I enable editing here because it's protected. You could see that the diff is set up here in exactly the same way, where we're pulling from file adapter first for that first set, pulling from file adapter for the second set, telling it to run, and then getting that first list of objects from up here and here. The fragment type that we're doing it is Revit identifiers, persistent ID, the diff config being set up, and diff fragment ID here. And then we're exploding this thing at the bottom of the Excel sheet, and then showing it in this tab over here with the modified object being here, the element ID I would need to pull separately, and then the name, number, occupancy. So you could pull out any Revit parameters that you really wanted to do. I think, so Alessio Lombardi was helping us to set this up. Getting the Revit element ID is not a parameter, so maybe that's the issue there, but we can go ahead and troubleshoot that right now, which is why it's showing up as 0. All right, so I'm going to enable editing and just show you how we would run through this. All right, so I'm going to Control-Shift-B and find my file adapter. With the folder file name, folder, comma, file name. Cool, we see that they both popped up now. And then the fragment type in this case was Revit identifiers. So I'm just going to go ahead and type that in. It is a fragment, so it's a type here. So it's that bottom one. The diff config in this case. So diff config, we're going to use that longer one here. Compute diff with fragment ID. I think that's the one. Nope.
Down a few more,
Yeah,
Kaylee.
this one, right?
Yeah.
Yeah. All right, so I've got that guy. So now enable property diffing. I'm going to set that to true. Store unchanged objects, false. Property names to consider, false. Should be all good there. And then diff with fragment ID. Which property was this? Ah, it's the whole engine method. It's hiding on me. All right, so we've got our past objects, first one, the current objects, the second one. Sorry again that you can't see my helper text popping up, but hopefully you can see it on your own screen. It's over on my left side here. The fragment type that we're doing is by Revit identifiers. The fragment ID property is this guy. The diff config is this one. Closing that up. Ta-da! You see that the objects are all here. And then if we go over to the show diff in this case, this is just reflecting those objects. So query reflection list. And then it's this bottom guy. All right, so in this case, I'm going to pull them from here. I want to see the modified objects specifically. And then the row that they're coming from. So I'm going to do row -2 to get the proper ID here. And we see that these are the objects that have changed so far, are these ones. Obviously, this is not perfect because it's not looking at exactly the same things. And in this case, if I want to Control-Shift-B and type in element ID, we'll see that that's a separate pullover property here. So it's that first one, querying the element ID of that object. I'm going to pull those down. So you can view the diff itself. So if you can imagine piecing this workflow together in real life, you could always create the diff first over here, and this being the diff object. You can actually pass that to JSON and pull that right into Excel. You can do lots of different work, but you can pass that diff and then set your workflow for replacing lights or plumbing fixtures or spaces or rooms or anything you can imagine. So again, utilizing this in a day 2 type of workflow would be really useful. And that's you passing those actual objects along that came along with the diff.
All right, looks like most everybody is back from break, so we'll go ahead and get started with our second workflow here. So this one's going to be focused on creation, interoperability, and analysis. So we're going to be looking at how we create BOM elements. So similar to how you'd go about in Grasshopper, for example, creating geometry, how we create data-rich BOM objects, how we send those to analysis. So we're going to start with creating our structure from room geometry. We're then going to move on from there to pushing BOM objects to analysis. We're going to use SAP Toolkit for that. And then based on that, pulling those sized objects, we're going to send those sized objects to Revit. So similar to a typical structural workflow where we begin with our our general setting out geometry. We go through analysis, we get everything sized, then we want to bring it into Revit for documentation and for our model. And then from there, we're also going to look at analyzing our BOM objects with LCA results. So we're going to do that with we're going to do a LCA toolkit to take those objects and figure out what the embodied carbon of the structural design that we've done is. So fairly representative of a typical structural workflow that we'd see on a project, including some bits and pieces that aren't really specific to structural, but are just related to our typical workflows interacting with Revit and geometry in general. So the overall workflow you can see here, we're going to start with the room geometry that we had before from Kaylee. So that geometry is actually going to be driving our structure. From there, we're going to create our structure as BOM elements, send to SAP, and then send to Revit and LCA Toolkit for our final outputs. So with that, I'm going to go ahead and pop over to Rhino. So you can see I've already got Rhino open with Grasshopper. So if you don't have that open already, if you guys can go ahead and just open up Grasshopper. And then from there, we're going to go to our scripts. So wherever your scripts are saved, if you guys can just open up the 200+201 script for those of you who are following along. And we've got that here. So this is our script that's going to be creating our BOM structure. So we're going to be creating elements, turning them into BOM elements, and then from there, we're going to send those to analysis. So just touching on some of the fundamentals similar to what Kaylee was going over. We've got our from JSON. So in this case, I've actually just gone ahead and jumped to already pulling in the JSON. Kaylee's already shown how we have pulled those from a file adapter. So typically we'd have a file adapter, pull from JSON, pull those specific files. In this case, I've already gone ahead and just internalized those two options that Kaylee had. So we've got those internalized as BOM objects. If I hover over them, you can see we've got our architecture elements.room, as Kaylee was saying before. And then one thing she touched on that I just want to expand on a little is this explode option, which does let us look at all of our properties. So as you guys are using the BOM and getting more familiar with it, use this component a lot. Get used to using it just to understand what properties there are on objects. So this is like a really handy shortcut. It's showing you all the properties on each of these objects. It's going to react to whatever you plug into it. So if I plug in different objects, it's going to show me all those different properties accordingly. You'll see how this changes. And one cool thing here that I want to touch on is those things that I just plugged in, and I get, you know, that we did this little bit of notification there, but some of this stuff that's in here is going to be based off of our native Rhino objects. So we can actually explode native Rhino objects too and get some of that information. Now, obviously some of it's limited, but you can explode BOM and non-BOM objects. So we've actually stumbled across some neat tricks we can do with that. But if we look at a BOM object, for example, we are going to get all of those BOM properties specific to that BOM object type. So explode is a really handy component to take advantage of for as you're working with the BOM, especially as you're learning and getting more familiar with the BOM. We also have our adapter. So in this case, I've got an adapter to a SAP model. What this is going to do is connect us to SAP. So for those of you who have SAP 2000 and are following along, you can actually connect to SAP and create this SAP model that I'm going to be showing. For the rest of you, feel free to experiment with these scripts during or after the class with different structural analysis packages if you have other analysis packages, or even just sending the different software, or like we're going to show at the end of this, sending to Revit as well. But in this case, what we're doing is we're connecting to a SAP model, and this is a SAP base model. So this is a fairly typical workflow we use where we have a shell model that might have like our load cases or other criteria set up already if we're not including that in our parametric workflow. And that's just a container model that we can push all of our parametrically generated geometry and data into to run our analysis, either through an automated fashion of running analysis, which I'll show you guys, or through just having that analysis file that an engineer comes in, designs, and then we pull that afterwards. So the first step of this script, again, we're taking those rooms that Kaylee had from before, so you can see that we've got those rooms here. Now in this script, what we're doing, and this is something I wanted to highlight, we kind of jumped ahead and covered this in the last set of scripts, but in this case, I don't have that fragment with the geometry of the rooms. But what I do have is this perimeter property. So these JSONs that I've internalized in this script, and that you guys will have if you're working with this script as well, do not have the, these were pulled without the pull config to pull surfaces. So in this case, all we have is our perimeter of the rooms, which we can see here. And this is a property on the room object. So a room has a property for a location, which is just a center point location, similar to how spaces are defined in Revit. And then we also have a property for perimeter, which is the curve that defines the footprint of that room. And that's what you can see there. So in this case, for the geometry preview, you'll see that we've just extruded those to show us what our volumes of rooms are. And if we were grabbing this from this diff, so I didn't want to get too redundant with showing the diffs over and over again, but this would be the diffing information that we'd be pulling from the workflow Kaylee was showing. And of course, then if we look at these two different options, we're going to get slightly different geometry as a result that corresponds with the geometry change that Kaylee showed. So we'd be able to read in that diffing and understand, because our entire geometry is set out based on that, how it's affecting our resulting structure, how it's affecting our, our parametric rules, our script, and how that could then affect our outputs as a result. So that's another case where diffing really comes in handy, is when we're reliant on certain inputs that are changing for a script like this, for a geometric setting out. We've got a couple projects going at the moment where this is actually super relevant, because this is exactly what's happening on those projects, is we keep getting input geometry changes that are affecting our driven structure. And we're able to highlight those changes and basically select, some of them we want to keep, some of them we will account for, and then other times we can push back and say, we've done the diff, we see that there's some changes we're not okay with. Can we compromise on this, or do we really have to make these changes? We can start to have that conversation around those diffs. So in this case, we're going to go ahead and look at the first revision, which we have here. And I've just set up this cluster that's creating our geometry. This is nothing to do with the BOM. This is just some Grasshopper geometry setup. So for those of you with this script, you can, you've got this already with parameters. Those of you who have done parametric workflows in Grasshopper, which based on intros, probably a lot of you, this is probably quite familiar to most of you. So we're just doing geometric setup based on that. But the real meat of this comes in over here, where we're going to create proper BOM objects. So we've got our geometry set out here, but that's just center lines. Those are just curves or points. it's not really data rich. There's not much we can do with it. So what we're doing here is creating these BOM elements, which is where we get really data rich information that we can then send to analysis or other locations. And in this case, what I've done is I have our set of bars here. So I'm creating a bar. The way you do that is if you do Control-Shift-B to do that search menu that Kaylee noted before and type in bar, you can see all different ways of interacting with bars. And for example, you can create one based on a start node or end node, or similar to the one I've got here, you can create it based on your line. And then you'll see that we actually have different options here too for orientation angle. So our bars do have an orientation angle where we can align to if it's a curved surface and we need to orient that bar. That way, that orientation angle is something that'll go through to analysis or to Revit or other locations as well. So we do have control over that, which is really handy for us as we need to, to find these properties that affect analysis, affect the way that we model documentation and all that stuff. So in this case, we're creating this bar. We've fed in the geometry, so fed in all the bars that correspond to these different members, which from the script have been sorted into 3 different design groups here, essentially diagonals in one direction, diagonals in the other, and horizontals. And then we are creating our bars, and the creating of the bars is where we really get a lot of information. So this is where we're using our data sets that we mentioned before. And in this case, we're using this match component that's going to let us search through a library for objects of a specific name. And what this lets us do is really easily get section information. And this is data rich section information. It's not just a string. These sections are actually, if we just explode them, sections that have been pulled from our data set with all of the information that comes with them. So this is like all the data that you get from your steel table, for example. So you've got sectional areas, you've got your radii, you've got all your structural properties, you've got materials assigned, and then obviously you have the name of the basic section as well. And so this is a really rich way for us to say what the bars are, say what kind of section they are, include all of this critical data that we need for whatever we're sending it to. And then from there, we have a bar that has a lot of information assigned to it. It has, obviously that center line that we mentioned, but then does also have all of our section properties, start node, end node, all of this information to go with it.
Sorry,
and that's
is that section information already built into BOM, or
yes.
is that, oh, okay.
Yeah, so if you, here what I've done is I've used this match component, which will pull from a library with a specific name. So this is pulling from a BOM library, but if you don't know what names to search for or you want to do it through dropdowns, the same information can be accessed through here. And if we go to section properties, US steel sections, HSS, this is the same data set. So you can see from this dropdown, if I explode this entry, that the 24 by 12 by 3/4 in the HSS data set is a section with a profile, with material assigned, with areas, et cetera, et cetera. So yeah, those are our data sets that are embedded within the BOM. So when you install the BOM, you get all those data sets as part of it, and you can access them through this component up here that looks like a dictionary, which is our data component. Yeah, of course. Any other questions before I move forward to look at how we assign panels and supports?
Just want to say that's awesome.
Sorry, you wanted to see the...
Oh, no, I just wanted to say that that's awesome.
Yeah, cool. Well, I'm glad you like it. Yeah, I think the data is one of the big things we've started to put a lot of energy into and that we're structuring around now, is since we have the framework and everything, being able to have, we started with those sections because it was for structural workflows. Like, you obviously need all your structural sections, but now we're starting to see a lot more power behind having similar data sets for things like EPDs for LCA. And now we're moving forward to, like, beyond that, looking at how we do like LOD 100 data sets for generic properties, for example. So like having like generic wall constructions for low performing versus high performing and things like that, that we feed into our workflows, and we really get a lot of value out of those too. So really handy. And again, there's just this dictionary up here, our data sets that you can drop in and explore. So hopping over to panels now. So in this case, I have a series of surfaces, something you're familiar with. These are, in this case, just the polyline curve defining the boundary of each surface. And I'm going to create panels for this. Now, in this case, for those of you who are structural engineers or done structural analysis, you might recognize what we're doing here in terms of modifiers. So I don't actually want to analyze these panels as structural panels, but I do want to be able to account for their weight in my analysis. And I'm doing that by applying modifiers, which BOM also supports. So we're able to do property modifiers so that we can basically put in all that data that we would have to put in manually in SAP or in our other analysis software. And by doing it in a generic way within the BOM, we can define a panel that's defined from an outline and then a property with these modifiers. And then whatever analysis software we're sending it to will basically digest this information and translate it into how that software understands those modifiers, which in the case of SAP is pretty similar to what you see here. It's just going to take each of these fields of the different structural properties of that property and then just change it from 1 to 0, essentially, is what's happening here. But we've started that off with a constant thickness property here that we've defined, this one not through a data set, but just through custom creation. So we're creating a tip panel property, and its thickness is 0.05 here. You can see the material that we've assigned. Again, this material is from a different data set. So this one is from the steel data set that we have for just steel materials. And another nice thing about these data sets is if you hover over the drop down, you can actually see all the information for the data set. So you can see where it came from. You can see who it's provided by, who the publisher is, when it was extracted, and then it's something that's in the works right now that's going to be released on our next release, our 5.0 release, is going to be data integrity as well. So we're also adding a notion to these data sets as we use them more and more of how reliable the data is, so that we know when we're selecting this data for our analyses if it's high integrity versus low integrity, if it's something that we can use to make very exact calculations, or if it's something that we should just be using for ballpark guidance, for example. So that's something that's in the pipeline, but it's really important to us that we are tracking this information on the data so that it's not just a bunch of data that we don't know, where it came from and everything. We need to know all that metadata as well. Based off of that, we've created our panel. And if we just explode that to highlight what a BOM panel looks like, here we have all of our BOM panels. Each of them is defined by external edges. Now, panels can have openings as well. In this case, we don't have any openings, but these could have internal openings for voids, which would be defined here in this opening section. And then the property that we've just defined there, as well as name and other native information for things like the unique identifier. And then fragments, which we started to touch on with when we pulled from Revit, which are basically properties that don't have to belong in an object, but can be added. So we have fragments for adding things like thermal information to an object, for example. And it gives us a flexible framework to add in all of that kind of specific data that we don't necessarily need, but that for certain workflows we might want to include. So those are our panels. And then last but not least, we're just going to create some support conditions. So we've got the points where the supports are going to occur. You can see those here. And then again, we've got a few different ways of creating support conditions. I'm actually just going to do the drag out that was mentioned previously. So drag a wire out, we get our options. We can define with our 6 degrees of freedom constraint through Booleans what all of our different releases are. Alternately, we can also just take one of these pre-cooked ones for something like a fixed constraint or a full release or a pin constraint. In this case, I've just said that these are all fixed. So I've assigned that constraint as a support condition on the node. And what I get is a node that is constrained with a fixed constraint. So when I send that to SAP, I'll have my support conditions ready to go. So those are our BOM elements ready to send over to our analysis. Before I send that over to analysis, are there any questions? All right, we will go ahead and, oh, yep, go for it.
When you're generating your canopy structure, you're not really connecting it to the Revit model, right? If you change a wall length, the canopy might cross your existing structure. Is that correct?
Yeah, so what I've done here for this generation is it's just extracting the room bounds essentially. Okay. And then building out based on that. But this, I would say, think of this as more of an abstract stand-in for whatever geometry generation you're doing. Mm-hmm. This is by no means a refined, finalized structure for the rooms that we're showing, more just a proof of concept that would often in our workflows be, a standalone script that's managing that geometry generation, for example, but it is typically responding to, grid lines or bounding boxes or Revit setup, or like you said, there could be a wall that's clashing and we're defining it based on that. Yeah. Perfect. But here it's just specifically looking at the bounding box of the rooms.
Perfect. Thank you.
Yeah, of course. All right, so once we've got all of these objects, I'm just going to go ahead and highlight those so that we're looking at our BOM objects. So this is our collection of objects that we're going to send to analysis. Before we send it to analysis, I'm also just going to show these the bars in 3D. So once we've assigned section properties to these bars, you can see that we can also see them three-dimensionally rather than just lines. So we're extruding based on those sizes. You can see that the horizontal members are smaller than the diagonal members because we assigned a smaller size here accordingly. So just being able to visualize in 3D is a bit handy to understand what we're sending over beyond just that two-dimensional line information. Once we've done that, we're going to go ahead and send over to SAP. And to do that, all I'm going to do is change push elements to analysis to true. Now, what this is going to do is if you don't have SAP open, this is going to open SAP, open the file that you've specified, and then create the geometry. So I'm just going to click true, and we're going to see SAP do its thing. Actually already had it. I think what I'm going to do for this one is I'm going to close it intentionally because I already had it running and show how it opens here too. There we go. So just going to restart that to show you guys what you would see if you didn't have it open. Let it finish thinking since I closed it. So now you can see that it's opening SAP. And if you saw there, the file name changed because it opened the file that we specified for it to attach to. And there we go. Now we've pushed over all of our structural elements. So pretty quick, pretty handy. And if we look in, you can see the sections assigned in SAP align with the sections that we had specified based on our BOM properties. So 4x4 by a quarter for horizontal. If we look at the panel, for example, so 6x6.5 on the diagonal, and then we have all of our panels in here to panel with the section assigned accordingly. So it's as easy as that for us to create our analysis model from our BOM objects. You have a few options for how you want to interact with analysis with the BOM as well. So in this case, I've just created an analysis model. For those of you who are following along, you could just do a save as now to whatever you want to call this. I'm just going to call it masterclass example. We'll save that up. Another option for how you interact with SAP, if you don't actually want to go through the process of going into SAP and editing stuff, is we also have execute methods. So I just wanted to make sure I highlight this. I'm not going to be using them in this demo, but we have these execute methods, and what these execute methods let us do is actually send commands to adapters as well. One of the most common that we would do is this analyze command. So if I set, you know what, we'll go ahead and we'll do it. So in SAP right now, I have a model, but it hasn't been run, right? Nothing's been analyzed. And usually if I was using SAP, I'd have to go and I'd have to click analyze. I could, you know, click a bunch of stuff. But what if we're doing a workflow where we want to iteratively study different designs and we don't want to have to open SAP for each of those? So these execute methods let us do basically silently operating these models. So just a quick example of that. If I have this execute with the analyze command plugged into it and I set it to true, you'll see that now SAP has run. So you can see that SAP has gone ahead and run and analyzed it. We get beautiful SAP graphics where distortions and deflections occur, but you can see that you see the lock sign, the analysis is run without me having to open SAP. So we can use that for workflows where we want to send geometry, run an analysis, and extract results without doing anything else in between. So really handy for some of the workflows we have where, you know, SAP is basically just running the analysis in the background. But for the sake of this demo, I'm going to show a workflow where we've actually already designed that structure separately. So in this case, I've pushed that the model that we just saw. An engineer has gone in and done their steel design. And then this other file that we've included in the SAP models folder, this one that includes analyzed, is a typical end product of the SAP analysis process, right? We have different sizes that have been assigned, in this case with steel design. So we no longer have just the typical member design, member sizing that we had before. We now have analyzed section sizes that we know work with the proposed structure. And what we want to do now is we want to be able to take that information, take all of this size structure and pull it back. And then in this case, visualize, run LCA, and send to our, send to Revit for our documentation for kind of our, you know, our final location to hold that model information in. So I've got this analyzed model open, masterclass canopy analyzed. And then I'm just going to hop back over to Rhino. We're going to get rid of what we did here. And I'm going to go ahead and open the other script that we had titled 202. So for those of you who are following along, please go ahead and open 202. Actually, before we do that though, are there any other questions before I hop over to that part of it?
I know we're dealing with SAP, but do you also provide integration with RAM?
Yes. So we have a RAM toolkit. We've gotten a lot of usage out of it in the US. It's especially like when we're doing like high rises where we need to do gravity design. So absolutely. It is a little bit more limited than the SAP toolkit and like the robot toolkit and ETABS toolkit, for example, just because of certain RAM limitations. So I will just, it's worth mentioning, but if you're bringing in a bunch of levels with beams and columns and doing typical RAM gravity design, for example, it works great. We use it for that all the time.
Gotcha, thanks.
Yeah, and if I would be really excited, so RAM toolkit's actually one of the ones I was leading development on, so I'd be really interested in, first of all, if you are able to use it, like get in touch and we'd be happy to help you along the way to take advantage of it. And also if you have any feedback on like features you'd want added beyond what we currently support, just we're always happy to get that kind of feedback and then to include it in our development. All right, any other questions before we move on to the second part? All right, I'm going to go ahead and open script 202 then. So again, for those of you following along, we just go ahead and open script 202. Give it a second to load. And this script, I've gone ahead and internalized what we're pulling. So for those of you who don't have SAP or aren't following along, but open this script later, you can already see what would have been pulled from SAP. So you don't have to rely on connecting to SAP, but I am just going to show the connection to SAP to make sure that you all are able to see that in action. So again, in this case, if I try to pull elements, I just want to highlight this, that you'll get an error saying you're not connected because we always want to make sure we connect to the adapter first. And in this case, we have our structural analysis adapter here. I have the analyzed model that I want to open. So I'm going to go ahead and say true. I have that model open already, so that was pretty quick. We're connected. And now if I want to pull elements, in this case, you can see we're pulling different kinds of elements. And Keely mentioned this last time, but just to expand on it, for pulling elements when we're putting in requests, you can do pretty complicated requests where you do like a logical and with parameters or filtering by types and different other properties of the object. So you can also do a really simple pull where we just say what type we want to pull and leave it at that. So in this case, I'm just saying from SAP, just pull all the bars. So pull our bars in SAP. I want to get all that information. And then pull all my panels in SAP. I want to get all that information as well. So I'm going to go ahead and toggle that to true. Takes a few seconds as we're pulling all that information. For those of you familiar with Grasshopper, which it sounds like as most of you, you'll see warnings sometimes, which is a typical thing you see in Grasshopper. And we've included in the BOM these warnings along the way to let you know certain things that are happening. In this case, it's just letting us know that a certain section property wasn't able to be read. In this case, that's fine. That's actually not assigned to any of the objects we're pulling anyways. But we do have these warnings that pop up along the way that you can always read to understand what's going on inside of the pull or inside of the push or inside of anything else you're doing, and helpful errors to let you know if things go wrong along the way too, why they might have been going wrong, and what information you might need to provide to get them to work. So in this case, we've got our bars. Those are all pulled. If I click preview, you can see that these have been pulled based on the SAP model. And again, if we explode those, we can see their properties. And in this case, what we'll see is the section property name here. If we just explode that section property, instead of just 4x4s and 6x6s, now we have all these different sizes based on the analysis, which is also what we're visualizing here. So we've been able to pull all that updated size information from SAP. If in the SAP model, for whatever reason, the engineer also needed to move certain objects around, we could choose to pull those new locations, or sometimes what happens is we actually want to keep the old locations and just update the new properties. So we have that option as well, which relates to some of the diffing that Kaylee was showing, where we're able to diff based on what changed, and then it kind of selectively take from what changed just the parts that we actually want to change. So pretty common when we're updating Revit, for example, to say we want to update sizes, but actually Revit has the more exact element locations because that's where we're refining that, whereas analysis might be snapped, might be idealized. So we don't necessarily want to always take the exact locations from SAP or from our other analysis models. So those are our sized bars. We also have our panels that have come through as well. And then just for some of the visualization that I'm showing here, I do just want to touch on some of our engine methods. So from this collection of sized bars that I've pulled from SAP, we're able to do engine methods for all kinds of stuff. Some of this is obviously super simple, like just getting the length of the bar, nothing too crazy. But these engine methods give us really helpful ways of extracting key data from our elements. So things like volume, for example, if we were going to do a tonnage, we can get that straight away from those bars. We can also get properties. So in this case, we have section properties, we have area. We could also show strength. We could show like our IY values to understand strength differences between the sections. And then here I'm just coloring by those different properties. So coloring if we want to understand where most of our tonnages are coming from. So where the larger volumes are, or if we want to just look at member lengths to understand consistency of member length or what our ranges are. But having these engine methods, these are some of the more simple ways of implementing that, and we'll show with LCA Toolkit some more advanced options. But the engine methods are really huge, right? Once we've defined these objects, being able to just get out whatever key information we want. And it's as easy as if we drag a wire out from our bars, for example, and I know I want to get the volume, I can just type in volume and I can see my different options for how I get that information. I can click it over here. For example, I could say solid volume for the bar, right? In this case, I've just done it for bars specifically. But being able to get all that information out is really handy. Similarly, if we look at our panels, and I knew that I have these BOM panels and I'm wondering what is the area, that I can just see, okay, I need to query the area. Now we just want to make sure we get the right kind of element. In this case, I'm going to do our element 2D, which is a more generic option. But now I'm able to get the area of every single one of those panels just like that. So no more messing about with a bunch of little grasshopper bits doing our geometric calculations and stuff like that. We have these kind of one-stop components to get all that critical information out from each of our BOM objects. Now from there, I'm doing a bit of conversion before I send to Revit. The nature of Revit, typically we want to set things up to align with things like type names, family names, certain parameters. So we typically do have this little bit of in between where we're adding, kind of salting in that parameter information that's going to go to Revit to make things really look right and really, read right on documentation and in their actual 3D location. And in this case, I'm going to start with the framing elements. So pretty straightforward, but we've just taken those bars and said whether they're beams, columns, or braces, or you can see the other things that are shown here. This is basically converting a structural element into a physical element, which is going to give us richer properties to send to Revit. Things like orientation. So being able to say if it's like top justified, for example, and being able to specify if we want to create beams or braces or columns based on Revit's nomenclature. And in this case, it's as easy as this one component to create those framing elements. So these are ready to send to Revit. At the top, it's something a little trickier. In this case, I wanted to show how we could use adaptive components. So for those of you who have used like Revit and these kinds of workflows a lot, I'm sure you're familiar with adaptive components. Really nice thing about the BOM and Revit toolkit is that we can also create any adaptive components derived from BOM objects. So in this case, all I'm doing is taking our BOM geometry and then creating a model instance here, which is a Revit toolkit specific object. So you might remember from the chart that, that Kaylee showed where we have OM, engine, adapter, and that all makes up a toolkit. So in the Revit toolkit, part of that OM is some custom objects, and this is an example of one of those, which is a model instance. So this is a BOM object that's specific to the Revit universe. It's specific to that world. And in this case, it lets us take a location and then family name and family type name information based on the Revit family. And we can create these adaptive component elements in Revit accordingly, which we'll see in a second when we do the push. So once we've done that, pretty straightforward. And now we have our objects ready to push over to Revit. And before I push those to Revit, again, I'll just ask any questions.
Just a quick one there, Eric. So
yeah, please.
The converter component that you talked about, converting the bar to physical element, does the end type become the same as the physical beam? Because that was going to be my question, is for structural analysis, wouldn't you want to use a beam if you had a specific one?
Yeah, so the bars are the specific beam. It's just the conversion. You'll see the namespace changes on these. So bars are structure specific elements that have all the properties we need for structural analysis and sizing and all that stuff. And then at the end, we get into something that's in the physical namespace, which is a physical object. So it's a different namespace and a slight difference in how we define these elements. In this case, the biggest difference is that from a bar to a framing element, we're specifying what the structural usage is, so that it's either, this is where we go from bars being any generic 1D element for analysis to a difference between beams, columns, braces, and then also having additional physical specific properties. So this is where we'd also layer on like thermal properties, for example, that wouldn't, like a bar doesn't have those thermal properties for like, I mean, it has the thermal coefficients relative to analysis, but it doesn't necessarily have other properties for like EPDs for LCA, for example, that we might have on the physical element.
Got it. So it's almost like a subset superset relation.
Yeah. So these, if we look at if you think about the diagram that Kaylee was showing before, let me actually pull it up on screen, because I think this is it's a really key point of how we approach this, right? Is like these different versions of the truth depending on discipline. And we've sorted those out from a code perspective by namespace. So like a beam and a bar are mostly the same, right? But there is a difference in how a structural engineer describes a beam versus how Revit, for example, describes a beam. And so we just use that as a way to capture the nuance of those different descriptions, right? That feed into the different analysis, different software, et cetera, et cetera. But they're all convertible, right? They're all still derived from, like you said, it's derived from like this parent notion of what these objects are. And it's just that certain properties are tweaking along the way for their custom usage.
Got it. Perfect. Thanks.
Yeah, of course. It's a good question. Any others?
From the way you're pushing, or well, you haven't got into converting, the way you're converting from to the elements to Revit. I'm guessing that obviously, this is me just thinking out. There's no opportunity to interact with, say, a Rhino inside, for instance. This is all in BOM's world.
It is, but another thing that's currently in development is looking at compatibility with Rhino Inside and how we kind of do the best of both worlds. I think there's some features of Rhino Inside that we don't do in BOM that we really like, and there's some things that we think BOM for our usage handles better than Rhino Inside for some of these things, especially when we get to like general notions of objects that are data-rich objects with a specified namespace, with a specific structure. So I think there's a place for both. We currently, so like in the installer that we sent to you all, there's not really anything to do with Rhino Inside, but that's in development, and we're looking at how we best take advantage of what Rhino Inside gives us, and then also try to basically add the BOM as like a module in Rhino Inside that anybody could use. If they're not necessarily using the BOM, but they're using Rhino Inside, they might as well get to use richer objects with more features.
Gotcha.
So we're looking at how we leverage that going forward. Hopefully that answered the question. I know it's like nothing yet, but in development. So in the near future, I would hope that there's in the 5.0 or 5.1 release, that there's some examples of interacting with Rhino Inside in ways for people to take advantage of that. All right, any others, or should we jump ahead to the push to Revit? All right, we will go ahead and looking at pushing to Revit then. So pretty simple as far as what we're doing here. Again, it's an adapter, it's a push component, and it's objects we're pushing. In this case, we don't need any config or anything, we're just pushing stuff. So I've got Revit open here. I've got the model open, and if we just look at the model here, this is the test model that Kaylee was looking at. So pretty simple model, just some 3D rooms. These are the rooms that we derived our structure from. And I'm just gonna split screen this so you all can see everything happening as it happens. So as soon as we click push, we're gonna be sending stuff to Revit. Now this does take a little while for those of you who are familiar with pushing to Revit, given that it is a database and given the API and everything, these things take a little while. So it's gonna take about 30 seconds. A similar workflow that we used to be doing way back when in the very early days of Dynamo. A shout out to Conrad, who's doing one of the other master classes, but we used to use ManaShrimp, which also took a similarly long time, but it's a similar workflow for those of you who have used ManaShrimp, as far as you're creating your objects and then you're sending to Revit, and they appear in Revit. That's great. So here we're just going to go ahead and push to Revit. I'm going to toggle that to true. we're going to give it some time to think. And as it thinks, it's basically just going through and populating, sending all this information to Revit and working on populating that information. No, it has not sent, which I will have to, oh, I've literally just done exactly what Kaylee did. Kaylee, we're learning from this, right? Okay, always remember to activate the adapter. This is,
It happens.
it happens. So if you don't activate the adapter, you get this handy warning, which hopefully is very self-explanatory as far as what you have to do. But by default, we have the adapter not active so that you don't have 20 instances of Revit all trying to connect at the same time and clashing. So we're going to select update or activate. So we're activating now. We are now connected. And this time when I send stuff over to Revit, we will wait about 30 plus seconds for everything to send. You can see the Grasshopper's not updating, it's just thinking. So we're sending all of our objects, which takes a little while. In this case, we're sending quite a few objects. Now, if you're just sending a few objects, it's super snappy. So it just depends on how much you're sending. We have workflows where we use, we'll send to Revit just a few things and it's just like a constant back and forth. We might have a loop versus other workflows where we're sending a huge amount of information to Revit and it's basically just a one-time at the end of the workflow, push everything to Revit with all the information it needs so that then we can do what we need to do in Revit. And this, I would stress, we're saying a lot about Revit, but this is a flexible workflow in the way we've structured BOM. We can do the same thing to push into a non-Revit similar software. It's just that, I think most of us in this class probably can relate to the idea that Revit is a large part of our work. Is in Revit in some way, right? Either getting things in, getting things out, getting things printed from it, et cetera, et cetera. So it is one of the most leveraged toolkits that we use. And what's one last time? So again, I just fell prey to the having to reactivate after I had activated Revit. Okay, now it's thinking. Now it's a good sign. So we'll give it 30 seconds or so now. And hopefully we'll get a structure in there. Any other questions or anything while we wait for the structure to push?
Maybe there's a chance to integrate Rhino inside because they use the same memory space. So I would assume that's making these kind of porting data a little bit faster.
I haven't actually benchmarked, which is it's a really good point because one of the things we are looking at is as we use this stuff more and more, getting more benchmarking and checking like basically where our performance gaps are. And I think Rhino Inside kind of gives us a free benchmark. So it's a good point. I would suspect as of now, Rhino Inside probably is quicker. Have you done like a push with Rhino Inside of like 1,000 elements roughly? Do you know about how long that takes?
I have not. I'm super new to Rhino Inside, so but I'm just curious.
I mean, I'm curious too. We haven't, because we have this solution, we do some work with Rhino Inside, but probably not as much as some other folks in the AEC industry. And I think it is, I mean, it's an awesome development, right? Like Rhino Inside and Rhino Compute are super cool. So we're excited to see how we leverage that.
Cool.
But I think one of the things is it does give us a good performance benchmark too for what we're doing. So now that that push is done, we have our structure. You can see all our different member sizes have been brought over. It's proper Revit geometry. It's also oriented, so you can see different cross-section rotations assigned to these based on the orientation that we assigned in that first step, where we were orienting based on the normal of the surface. So all of these have been kind of twisted along the surface. Now, obviously, we could also just do no orientation and just have these all be vertical in our kind of default Revit format, but good to highlight the orientation option as well. And we also have our panels. So in this case, for our panels, I've just created a super simple adaptive component, the simplest imaginable. It's just a 3-point triangular panel with a glazed option and an opaque option. And in this case, all we've done is created from our panels that we extracted from SAP, each of those 3 corner points to create all these panels. Obviously, in typical workflows, we have more complex families for this. Shanji Jewel, for example, was one that used a really early version of this kind of workflow with a triangular family that was super sophisticated, had your frame edges, your different LODs, all kinds of parameters for open versus closed and all that different stuff. So you can get pretty crazy as you get more and more into the details of this, but the ability to push based on that defined geometry and family type gives us a really rich connection between the detailed Revit specific stuff and the other stuff that we're doing within our BOM workflows for analysis and for other processes. But that gets us to the our kind of end result here in terms of a structure in Revit. So the last bit I want to cover before we wrap up is LCA, but I just wanted to, any questions on that before we jump over to LCA? Okay, cool. So LCA for this demo is quite simple and straightforward, and that is very deliberate because we've made the LCA toolkit and the processes involved as simple as possible so that people don't have to view LCA and getting things like embodied carbon as a additional process. It's more something that you just kind of get for free, plug and play, so that at any point you can understand what these critical values are. And in this case, what I'm doing is I've taken in these framing elements that we created. The one thing that I need to manually assign is this piece here, which is what EPD is going to be used with our elements. For those of you familiar with LCA, life cycle assessment, it's kind of the critical piece of it is these EPDs, which are environmental product declarations. They're essentially signed off accredited documentation that says how much embodied carbon is associated with certain materials or products. So in this case, we have from the AISC data set, again, we are using these BOM data sets. In this case, we have a data set for steel that's been sourced from the EC3 website, which is buildingtransparency.org. EC3 is super cool, all the stuff they've been doing. We have a live link to them as well called the Carbon Query Database that links to their underlying database, so we can pull EPDs from their database for any specific products we're using. But in this case, we're just using our general data set and assigning an EPD. So the EPD we're assigning here is the fabricated hollow structural steel sections. This is an industry-wide EPD that was put together by AISC. And we're assigning that to our framing elements. And getting our critical LCA values is literally just as easy as plugging into these components. So once we have elements that have EPDs assigned, often on a larger project with a bunch of different materials, this would mean assigning all of our different materials based on the different elements that are being assessed. So based on their materials, just assigning an EPD on a one-to-one mapping, or sometimes on an element basis based on categories or things like that. Once we assign our EPDs, we plug them into this evaluate component. This evaluate is going to take our EPD, take the phases that we want to evaluate against. For those of you familiar with LCA, there are different phases. A1 through A3 are our typical phases that we assess. Those are just for when basically the product is being manufactured until it leaves the factory to get to the job site. But you can also look at your other phases as well. And then which metric we want to look at. More often than not, we're looking at global warming potential. That's by far the most critical metric that we need to minimize at this point, given the current climate crisis and the fact that we want to minimize embodied carbon. So that's the one we're most often looking at. And then from there, that's going to give us these result objects. Again, if we explode the result objects that we get out of this, they contain the quantity, so the value that was received, the metric that it relates to, the object it was derived from. Also, we can get like the EPD that it was based on so that we can use that for documentation purposes. So you can see each of these shows the phases and then has that EPD as well. And then with this component, we're just taking those to get a total value. In this case, we're getting our total quantity of global warming potential. And based off of that, we're able to really easily see what the global warming potential of our proposed structure is. Now we have a more involved workflow if we're doing a project-wide LCA, where we can we create this singular result object that we actually store in a central database for project benchmarking. When we're doing this, rather than just having a bunch of elements we feed into it, we actually curate it by scope. So we look at we create a project lifecycle assessment. This project lifecycle assessment has all the data associated with that. So our LCA scope includes all of our building information. Our structure scope would include all of our elements from the structure, categorized by the different components they belong to. And what that lets us do is calculate the total global warming potential for that project with all of this metadata for what the building information is, how the global warming potential breaks down by category and things like that. And so we've been using that for our internal databasing for project benchmarking for embodied carbon. So for each project, we're basically plugging in all of our different components, slabs, walls, et cetera, along with all the project data. We run our analysis here, so we get our result, and then these results are stored in a central database that we can query later on to understand like average embodied carbon of different building types and where that distribution lies, what's usually the area that has the largest embodied carbon associated with it, so that we can understand routes to minimizing those values. and other things like that. So that's been a really important piece of this of the LCA toolkit effort, is being able to create like a curated way of recording results that can be benchmarked and that can be collected and then, explored moving forward. And with that,
I'm going to add
brings
one
us-
more little
Oh,
thing
please.
there, Eric.
Yes, please
So
do.
that number of 341,000 kilograms CO2 might be completely like you don't know what that number means. We do have a fun little evaluate method being added in now to make that equivalency. It's a data set from the EPA so that you would know the number of trees that would have to be sequestered in terms of the amount of carbon, the number of cars per year on the road, miles driven, gallons of gasoline, all of that good stuff, so that you can make that number relative to things that we're familiar with as normal non-sustainability expert humans. So it's a good one that we're adding in.
That's a really good point. And we also, on the project LCA evaluation I was showing, the way we store that data, we include a per area value, which is currently the kind of best in practice for LCA, but still doesn't really tell the whole picture. But we do have that so that it gives it a little more context on a project to project basis. Yeah, what Kaylee mentioned is great for giving more context to what that really means. I think when you see it in terms of things like trees planted or in terms of miles driven, things like that, it really drives home basically how much worse buildings are for the environment than things like driving, for example. Like it's pretty incredible when we're designing these buildings, how much embodied carbon is going into them. And it's really important we try to minimize that.
Awesome.
Do we have any other questions? If not, we can just move into a bit of a wrap up. I think we've robbed you guys of one of your breaks, but hopefully that's all right. But yeah, any other questions or comments or even just general discussion at this point? I think it'd be great to hear your guys' thoughts or any more information you guys would want.
So when I install the installer, does it like automatically populate every one of the adapters already created or toolkits already created in all the other softwares?
Yes. So the installer manages all of that deployment. We're also, hopefully you're not sick of us saying coming soon, but also I believe in the 5.0 release, the intention is that installer is going to have custom installation where you're selecting your toolkits so that you can be a little more specific. But as it is now, it's deploying all of these. So you've got your Revit add-in ready to go, Excel ready to go, and all these different toolkits and adapters ready as well.
Cool, it's handy.
Yeah.
And on top of that, if I have to maybe install a new software that I didn't have, do I just run the installer again and it figures it out?
So you shouldn't have to rerun the installer unless it's I think new Revit versions would be the one where you would have to run it. But if it's like connecting to new analysis software, for example, or something like that, you don't need to rerun the installer. The toolkit will still function as it did before. And basically when you push with that adapter, if you had pushed with that adapter before you had it installed, it would just give you a message that says that it failed because you don't have that software. And once you have it, the push will work essentially.
Eric, regarding new adapters, are there any new adapters in the works for other software? For instance, game engines like Unreal and Unity?
Yes, so there is, thank you for asking that. That's one of my current projects, so I'm happy to speak to that. We have an Unreal toolkit. In its current state, it's a little bit prototypey. It was developed as a proof of concept that we're now using to define what we're going to do going forward. But if you go to the BOM, you can actually see, maybe I'll just grab a link to that. All right, I'm going to pop this in the chat if I can. All right, well, I'll paste it in the chat after, but if you go to the BOM and search Unreal Toolkit, you can see the Unreal Toolkit. Again, you'll see that most of the development on it is a little bit outdated now because we're currently under works on the next phase of that. But the idea is we want to start connecting more with platforms like Unreal, platforms like Unity, web-based platforms, things like that. we're putting a lot more energy now into how we work towards game engines. And that's one of the main things that my time's going into now, is defining our game engine strategy and how we, from a development standpoint, we already use them a lot for like visualization, but I think it's an understanding that using them just for visualization isn't enough anymore. And now we want to start using them as kind of, pretty soon, instead of Revit, we're going to use something like Unreal as our designing home base. That's the way I see it. So a lot of our development is looking at how we build out toolkits and support adapters, workflows, things like that, built around game engines instead of built around things like Revit. And to that end, I would say if you're interested in developing a toolkit that connects to a game engine or helping with that, that would also be amazing, because I think, at least personally, in terms of the development space, it's the most exciting space right now, is how we in the AEC industry leverage that technology.
Yeah. Agreed. With the, just a quick note on that, with Revit, there's already in the API methods for generating contents, for placing a wall and so forth. But with game engines, you basically have to resort to procedural meshes for geometry generation, and that's up to you, or up to us, to define how we want to generate that geometry of contents.
Yeah.
And make it changeable, parametrically.
Yeah, totally. And another thing, if you're interested in that, as far as the BOM world, we have render meshes that are starting to handle that translation. So we're currently working on building that out. It already exists in the code base, but working on building that out so that we can handle object translation, where you go from a BOM panel to a game engine friendly object that has render meshes associated with it, with LODs and all that kind of already made.
Which library are you using for mesh generation in BOM? Is it the VD3D from .NET or something else?
So we've been using TriangleNet for some 2D operations, and then as far as what the render mesh platform is, I'm just getting it loaded up right now so that I can actually show it rather than talk about it, because I feel like that would be better. Give me a second. Let me just get it open.
That's actually a very good topic to develop in an open source project, because it's hard to find, or it's hard to get to a good like a geometry kernel or library, that the ones that do everything and more than what you need are expensive. The ones that are for free might not do what you need. So it's nice to have an open source project, some guidance on geometry developments.
Yeah, totally. And I mean, that's kind of our ethos with a lot of this open source stuff, right? Is like, it's mutual benefit. It's stuff that the fact that we need to define it means probably other people do too. And then also, like, the more that people are able to consistently define these things, the better. So this is just a snippet of the base render mesh object, which is just derived from our BOM vertices and faces. It's, this is just the primitive, so it's nothing too crazy. But if you explore here, you can see some of the inner workings, and then we also have test files associated with this that show how they correspond to our objects. But I think it's early days as far as how we're handling these, because the next big step is when we get into like, okay, these need to end in a game engine with LODs and with things like UV wrapping, with all the challenges that in the AEC industry we typically just like ignore because it's hard, basically. And like, we don't really have to deal with it, but like, as soon as game engines become the central platform, a lot of that is going to move to the center. So we're trying to get ahead of that in terms of how we define these objects and handle them. So that's, it's something we're currently putting a good amount of energy into.
Another quick question, Eric, is regarding the web client or web implementation of BOM.
Yeah.
For the 3D graphics, have you looked into, I know it's not a standard that's out there yet, but it will be fairly soon, apparently early next year. Have you looked into WebGPU? Because with the demonstrations I've seen, the performance of displaying graphics is almost, in some cases, 100-fold faster than WebGL and its wrappers like Three.js and Babylon.
Yeah, so
Is that? Go ahead.
I haven't been. We've got a software engineer basically who's like our web expert who's been doing a lot of that research, and he's been talking about it constantly and is really excited about it. I can't speak for him on what we've seen with it so far because I don't really know, but I know that he's mentioned being very excited about it and has been digging into how that can improve performance for us. He's also the one who was toying around with Blazor a while ago and has identified that as basically our, as far as web platforms, our most promising option. So we are working on that development, and then using like Vega Lite for data visualizations, for example. So that's another, just worth mentioning, like another kind of tool set that we're building out now, that's more towards the web-based side of things. I think we see a lot of, and I've been shouting it out for a while, and so has he and a few others, but we kind of see the game engines and web are kind of, we should have been using that as our central platforms a long time ago, and now people are finally coming around to it. So I think that's, over the next couple of years, I think that's where most of the energy is going to go towards, honestly.
Yeah.
We still have to, deliver projects and do good engineering and everything else too. But I think for the exciting stuff and for more of the exploration, it is going to move that way.
Yeah, totally agree. The game engines and 3D on the web.
Yeah. Yeah, really good questions. Thank you.
I think one of the last questions that I have is, it seems like BOM works with data-rich objects, right? These are not just geometries, but they have properties. But what if sometimes we work with designers who doesn't necessarily want to deal with sort of all those, putting data in all those fields, or doesn't even have, say if they model things in Rhino, they just model things, and the probably the best sort of organizations they will have is through layers. So there's still a little bit of a translation before it can be turned into analysis ready geometries, right? We have to sort of manually imbue them with data in a way. I'm just wondering if, like, is that something that you encounter in your workflow, or is it something that you, like, what are your thoughts on that?
100% something we encounter in our workflow. I think part of what we've done here is simplified that translation, but we certainly haven't eliminated it. For example, it's fairly common still, if we're using a BOM-centric workflow, that the first step is take Architect's Rhino model and read the layers objects are on and in some way map that to properties. Right. And I think we kind of just see that as something you're going to have to do, because there is some user expertise of how those things map, right, in some way or another. But definitely there still is that little bit of sticking point of like, what are things being shared in? Like, what format are things being shared in, and how does that translation occur? Are we reading in Rhino, taking in layer information, taking in object information, and then how are we translating that to a BOM object? But with the adapters, we've tried to streamline as much of that as feasible.
Right, and I see like the diff engines being extremely handy in this case, because I don't have to sort of redo the whole data, rich object pipeline just because someone sent me an updated model. I can just work on the updates, the delta.
Yeah, and to that end, you can also do with diffing, you can do diffing on the primitive geometry types too. So like if you create one. So if I just I've created like random curves here. We have a component to create random curves, but basically, if you're creating a curve, right, you don't have to have a data-rich object. There are BOM primitives for like geometry, for example, and you could run the diff on that instead. So like you could do your diff on two different curves that you have, rather than doing the diff on like the super data-rich objects.
And it's just going to tell me how those two primitive geometries are different, or?
Yeah, it's just going to flag that they're different and then show you which properties are different.
I see. Cool.
So if you did that with like for example with a Rhino model, you could do that, and it would just flag, you know, if two surfaces changed and the rest was the same, it would give you those two surfaces. So you could still run it in that way. But if you were doing like if you wanted to see like if layers changed, for example, there would be the extra layer of then setting the layer name as a property
Right.
on the BOM object to then run the diff afterwards. So
Right.
there's still that one intermediary step.
Cool.
I'd have also maybe a following question. I was wondering, when co-designing or collaborating, I see that we can use a Mongo database where everyone works on their machines and they pull and push to this Mongo database. I can imagine that the data would be structured well if we push the whole BIM model from Revit and then we work with it. But how does it work in early stages of design when we push step-by-step customized elements that we design in Grasshopper? How are they stored in this database, or like how is the structure? We have rooms, we have doors, window, column. What happens exactly in this database?
Yeah, really good question. For that, for early stage, we'll often use JSON files rather than a database if we're just looking at specific pieces. So that's like where Kayla was mentioning before, for like the rapid prototyping workflow, because we're not really looking at the whole thing. We're more looking at specific pieces of it that are relevant to each person or each discipline. When we are leveraging the central databases, it's more often for, like you're saying, maybe later on, or when we do have more organized data or more structured data. We also would use the databases a lot for just like collecting data as well. So like the database, rather than being the definition of the model in a rapid prototyping workflow, would be the definition of the outputs. So we would run through JSON files the specific analysis for each specific discipline based on the like JSON file of the objects they need. But then all of the disciplines would send their results to the Mongo database so that we have centralized result data that we can query or do visualization on or things like that. So it really depends. I think that's where things get really project specific or workflow specific, is like, what is the nature of the data we're getting and what are the workflows that are relevant to the project? Because obviously we're not just, you know, different analysis is important for different projects. Different insights are important for different projects. And then based off of that, sometimes a database might be your central source of information, but more typically it's more targeted JSON files of smaller pieces of just what's useful for each discipline, and then all of that coming together at the end. I think we're coming up on time. Maybe we could do, yep, one more question, please.
A question, are you using I see there is IFC toolkit.
Mm-hmm.
Are you using the IFC toolkit, and is it well developed?
I would say we're using it a bit. I wouldn't say it's super well developed. Honestly, we don't use IFC very much, just based on the fact that as it is now, we see that we have better options for interoperability. So typically when we're using IFC, it's because other people need IFC, basically.
Can we export a whole model in IFC, or is it just pieces of IFC, or is it fully functional? I mean,
Kaylee, I'm not sure if you've tested lately. I know that it's somewhat functional, but I would be hesitant to say fully.
I know that IFC is working on coming up with a stable JSON format for their own purpose.
Yeah, true. Yeah.
And I think once that comes on board, it'll be much more interoperable with the system that we have. So I think
that's a good point.
Yeah.
Yeah.
Okay, thank you.
That's actually, Kaylee, glad you mentioned that, because once they do go to a JSON friendly format, since we serialize to JSON, it'll be a lot easier because we could just basically tweak our serializer to match their schema.
Mm-hmm.
Okay, perfect. Thank you.